Hi, this is Dave Prout, and in this two-part series on lighting and post-processing, we'll take an exhaustive look at two of the most powerful features of Epic's Unreal Development Kit. We're going deep into the lighting systems in Unreal, and we'll show you how to take advantage of everything from the earliest features such as lighting channels and light mapping to the current state-of-the-art light mass using the Swarm Distributed Renderer. We'll show you how to use any object as a light, how to set up light environments using high-performance composite dynamic lighting. We'll dig into all types of shadows, including shadow volume, shadow buffer, modulated, sign distance field, shadow map, and light map. We'll set up exclusive light linking relationships using light volumes, light classifications, and lighting channels. We'll create gels by using light functions. And we'll walk you through the evolution of lighting in Unreal Engine 3. We'll crack open Unreal's best-of-class post-processing tools, and we'll show you how to set up post-process chains to custom build unique effects, how to manipulate real-time ambient occlusion, ways to set up post-effects in small contained spaces or across a map. We'll tune motion blur and light bloom. We'll tweak colors, desaturate, and punch values to tweak overall look and feel. And we'll cover some special image manipulation techniques using material-based post-processing to do things like edge detection, distance-based color blending, and filteresque techniques. Combined into one DVD, Jim Magill and I will show you how to unlock the power of lighting and post-effects to bring richness to your scenes in Unreal Development Kit. Let's get started.
Greetings, I'm Dave Prout, and this tutorial covers post-process effects in Epic's Unreal Developers Kit. I'd like to thank Jim Magill and Eat3D for the use of this great scene for this tutorial. Now to start out, post-processing in Unreal uses a post-process chain node, and it's pretty hard to find if you don't know where to look. The best place to look for it is to open up your INI file, and it's located in your C drive, UDK, and this is the version that you've got installed. I'm using the January of 2010 version. In the UT game folder and inside the config folder, and the file is defaultengine.ini. And if you do a search here for default post-process, you'll go down to a line where it's defined in a package, and it's default post-process name. And the package is effects, hit effects, and the node itself is ut post-process _ console. So let's go ahead and open that up. Open up my content browser. And go over to all types here. Instead of favorites, select all types and scroll down to post-process chains. And with that selected, we'll go down to the package that's referred to in our INI file, which is right here, fx hit effects, and it's calling for ut post-process _ console, which is right here. So let's open that up and have a look. Now I've cleared out all the other nodes in my chain here just for the purposes of this tutorial, so you might see a few more nodes in here in yours, and that's okay because we'll cover those too. But just to start out, we'll start with scene render target, which is the kind of the anchor of your whole post-process chain. Scene render target is basically the rendered frame coming out of the renderer prior to being drawn on the screen. So this is where all post-process effects start. Now if you right-click in the gray space, you can see all the different post-process nodes that are possible to add to your chain. And we'll start out here. It's an ambient occlusion effect, blur effect, depth of field and bloom effect, depth of field, bloom, motion, blur effect, uber post-process effect, material effect, and lastly motion blur effect. Now you might notice that there's a lot of redundancy in this list. For example, blur is referred to here, bloom is referred to here and here, depth of field is referred to 2 places, motion blur is referred to in 2 places. The reason for this is because over the years, as Epic builds on its technology, some of these nodes become obsolete and they create new nodes to replace the old nodes. So some of these nodes are here just because of legacy reasons and really are not recommended for use. And those nodes for us are going to be blur effect, depth of field and bloom effect, depth of field, bloom, motion blur effect. These 3 here are pretty much useless. and you shouldn't use them. I wouldn't recommend it. Instead, use Uber Post Process Effect, because this encapsulates all three of these all in one effect. Epic came up with this when they were shipping Gears of War, the first one. And in fact, if you look at any of the old Gears builds, you'll see that they use this one mainly in all the Gears stuff. So if you look down here at all the different parameters that you've got with this node, it includes all those other nodes, depth of field and blue motion blur effect, and so on and so on. So let's hook this up real quick. Before we get into all the details and all these nodes and what they do, I'd like to show you how to set up post-processing in your scene so that you can preview it and see it in real time as you're working. It's important to note that post-process effects can be defined at three different levels or groupings within what you're working on. The first is what we talked about here, is at the post-process chain node. When you change things at this level, it propagates out to every map that you're going to create within Unreal. The second place is in the world properties. You go to the view menu and world properties. You unroll the world info node here, or world info section here. Locate this default post-process rollout. Here you'll find a lot of similar settings that you will find in the post-process chain, except for these will be defined per map, not across all maps as you'll find in this post-process chain. So if you want a post-process effect to just be on for a certain map, this is where you would define it. A third location is on a volume level, and we'll cover that in a little bit, but the idea is that you can create a volume out of a BSP brush in Unreal and set it up as a post-process volume, put it anywhere in your map, and then you can have custom local post-processing just for that one volume. So back up for a second. The first place that you define it, post-processing, is back here in the chain. And again, if you define it here in this chain, it means that it's going to be happening across your entire game. The way to fix that, and have it happen down at the map level, for instance, if you scroll down to any of the bottom on any of these nodes, on here or here, any of the other nodes, you'll find the section called Post-Process Effect. And it's got these same 5 settings across all of them on any node. There's Show in Editor, Show in Game, and Use World Settings. And to cover those 3 first here, Show in Editor means you want to see the effect when you're just in the viewport here, looking at it in the viewport. Show in Game means when you're going to run it inside of Play in Editor, right here, Play in Editor. We're going to play outside of the editor using a command line launcher. And Use World Settings means ignore this post-process chain and instead use the world properties. Or if there's a volume in the scene, use that volume. That's really important to remember, because you can pull your hair out going crazy trying to figure out why you can't preview your post-process chain. And it'll end up being one of these checkboxes. It's happened to me a lot. So I like to have them all on all the time, because I like to control everything down at the map or the local post-process volume level. But you do have to have the chain set up correctly here for those volumes, or for those settings to work. So we'll cover those. One last setting here is the scene depth priority group, DPG. There's 5 different options on this list. Almost all the time you're going to want to choose post-process. Almost every effect in the post-process chain you're going to want to set to post-process. Occasionally I've set it to world, but that's only for doing special skybox work where I don't want the skybox to be included in the post-process effect. And I haven't used it very often. It's pretty rare. So I recommend using the post-process setting, which is the default. Now lastly, there's this effect name. An effect name is a way to tag your post-process chain, and you can have several chains existing in a package. And you can tell your engineers that you want to call a certain post-process effect at a certain time, a certain event that happens during gameplay. For instance, if you get hit with a special weapon by an enemy and you want the screen to turn blue, then you could tag this with a special tag. This is like blue hit. And the engineers would call that tag in code or in script. And your screen could turn blue and be controlled via script instead of via this chain or through Matinee or any other place. So back to previewing. We've got all of our checkboxes turned on so that we can use the world settings here. We'll go back and look at the screen. And we notice we're not seeing anything now because we've told it to use the world settings. And the world settings are not set up right now to show us anything. So we'll go to our world properties. Make sure that we've got some things turned on here. We've got some bloom set up. Let's turn on depth of field. We've got some depth of field turned on. Got motion blur turned on. And that's about it. So we have some things set up for the world. Let's make sure we have our viewport set up to preview this post-process effect. So you need to have post-process effects checked. In order to do that, you got to go to this little triangle drop-down button, go to Show, and then down to Post-Process Effects. That needs to be checked. Also, if you're going to be using volumes, it's good to have this button, Post-Process Volume Previs, enabled, so that you can preview it real time while you're moving around inside your environment. And last but not least is this G button, Game View. In prior versions of the UDK, this button wasn't here. You can locate it by going to the little pull down and going to Game View. You can also just push G, and that will enable Game View. Now, if we try to preview some of these things in our map here, I'll just toggle a few things on so that you can see that it actually does work. Change your depth of field focus radius to 200, and you can see the whole screen blurs out with the depth of field blur. One last thing to point out, just to help you guys have as little confusion as possible. Show in game. This little checkbox here is tied to this game view mode. So even though you're previewing in the editor in this viewport, if you have game mode selected, it's basically the same thing as having show in game turned on. So if you have game mode off, this won't have any effect at all. But this will, because it's now you're in editor mode. But if this button is on, now you're in game mode, and so show in game is what will affect your scene. That's another reason why I like to have them all on, just to prevent myself from going crazy. So wrapping up our chain here, let's go ahead and add a couple more nodes to complete our chain. We're going to add a motion blur and an ambient occlusion effect. And it's important to note that you can put any of these in any order, but their order does affect the way that your resulting frame is rendered, because it starts from the left and goes to the right, and the right node is the one that happens last in sequence. So it can impact your performance and your look depending on the order of these nodes. And programmatically and rendering wise, if you were to bloom first and then motion blur, it would be different than if you motion blurred and then bloomed, and you'd have different performance implications for both of those, and different look and feel, although it'd be subtle for both of those as well. And I just want to note that you can really impact your performance here using this post-process chain. All post-processing is expensive, and if you were to take advantage of everything that's in the chain, you'd be visited by a graphics engineer pretty quickly if you're on a game team. It's important to know how aggressively you're using each node and just keep tabs on it so that you keep it responsible. So we've covered what the post-process chain can do and what the world info level controls can do for you. And this one again covers the whole game, everything that you're doing. This one here just covers the map that you've got open. Let's have a look in what post-process volumes can do for you. Close these down. I'm going to hide this skybox so I can work a little better. I'm going to hit B for my builder brush. I'm going to go to front view, so confirm that it encapsulates everything vertically in my scene here. Okay, now to create a post-process volume, I'm going to go down to this volume button here, add volume, right click and go down to post-process volume. When I click that, if I turn off my builder brush, I've got a purple volume here that remains, and that's my post-process volume. If I hit F4 for properties on that, and I go to that volume, open up the settings, they look really, really similar and actually are just instances of the properties here in world properties under default post-process. All the same. Now there is this one setting above the settings here called priority. And what this does is it controls the rendering or the preference order for the volumes if they're nested. If you have a nested situation where you've got a series of them enclosing one another, say for an exterior and then an interior and then a deep interior room, and 3 volumes and they're all nested. You could set priorities for those volumes in those cases, and then you'll get what you expect. And instead of, say, the exterior overriding what's happening on your interior one. So just remember that. I'm going to go ahead and duplicate this node here. Control W. Control W again. Get 3 different volumes here. And I'm going to build my geometry, which is always a good idea when you're working with brushes so that everything gets updated and refreshed. And I go back into my perspective view here. I'm going to unhide my skybox so I don't get that weird fuzzing out at the top here. Okay, now let's go to our volume that we are currently inside of, our camera is currently inside of, and open that up, hit F4. Quick thing to look at here is that you can control scene, shadows, midtones, and highlights right here through these values. These 3 settings are also visible through your world properties, world info node, and through your post-process chain. In your Uber post-process effect, they're right here. One thing I wanted to cover is that this is kind of unintuitive with these numbers here. Scene shadows, if you increase the value here for shadows, you will be increasing the darkness that you see. And X, Y, and Z just is R, G, and B. So if you increase X, you'll get a little less red in your scene. Well, you're darkening by red. If you do all 3, you'll be adding dark across the whole scene here. There's 0.1, so light touch is important to use with this setting. I'm just going to add 1/100th here from the default of 0. You can see some blacks starting to appear here pretty seriously in the scene, pretty heavy-handed already just for such a small amount. Now the highlights function inversely. So if I take a lower number, my highlights will get brighter. For example, if I go from 1 to 0.9, I'll see my highlights increase. That was pretty subtle. If we go to 0.1, you really see it. Now just something to point out is that the method that Epic uses in Gears of War is to do really saturated textures and really saturated lighting in their scenes, and then come in here with scene desaturation and desaturate it down quite a bit, and then go over top with this correction here, which just heavily overcorrects the frame and gets that really gritty Gears look. If you're able to open up any of the Gears builds and look at how they set it up, that's how they do it. So here's an example of what you can get by playing just with the color. And you can control just one color at a time if you like, just to get a certain color that you're looking for. And over the course of this tutorial, we'll cover the rest of these as well. Let's go ahead and set up our middle and our far volumes as well, so we can transition between them and see the difference. So making this middle one very red. Let's make this far one really desaturated. Just a touch of color in it. Turn up our bloom on it, make it more noir. Okay, there we've got a third volume settings. Now that we've got our post-process volumes in place, let's go ahead and see what happens when we travel through our scene real time in our viewport. Now, an important thing to notice is here in our roll-up, we've got something called a scene interpolation duration value. And this is a time in seconds. Right now, by default, it's set up for 1 second. What this value is for when you're transitioning between post-process volumes. And this will allow it to crossfade between post-process effects over this length of time that you establish here in the setting. Now you notice that it was instant in what we just ran through in viewport, because in the viewport it doesn't preview this value at all. It's just instant. In order to see this value working, you have to actually run it in the game. So let's go ahead and do that now. Okay, now you can see here it's instant as I move back and forth. And now when I run it in Play and Editor, now you can see the blend. See before and after. Okay, so that pretty much covers using local post-process volumes in Unreal. For the next segment, we'll cover depth of field. Now for this one, I'm going to go ahead and dial back our settings that we have on this volume here so that they're not quite so gritty. We can have a better example of, have a little better idea of what depth of field can do for us. I'm going to go back down here, right click, reset to default on these. There we go. Back to the original settings. I'm going to pick a location with a good foreground object here so we can really get a good look at what this can do for us. Now, depth of field is contained right here in all of these settings that start with DOF. You've got blur bloom kernel, blur kernel size, fall off, focus distance, inner radius, focus position, focus type, interpolation duration, max far blur, max near blur, and a modulate color blur. So let's one at a time here. Blur and bloom kernel size is only useful if you're going to have separate blooms from your bloom effect and your depth of field effect, which isn't very common practice. So I'm just going to leave this value alone because I've never used it, but it's there if you want to check it out. Next thing to look at is, let's jump down a few so that we can actually start to see some things here on the screen. The two most important values which you'll be messing with depth of field is focus distance and focus inner radius. And in order to talk about these two, first have to choose a focus type. Focus type, there's two options. There's distance and there's position. Almost all the time you're going to want to choose distance. Distance means distance from the camera's location. How far away do you want the focal point to be from the camera's location? Position would be world space position. Like if you knew that you always wanted this ship to be in focus, no matter what, no matter where the player was in the world, you could set the world position of where the ship is right here And that way the ship would always be in focus as you run around the world. That's not usually what you want in a first-person shooter, but it's there if you want it. It's useful for things like cinematics when you want to make sure that the character's face is in focus all the time and you know where it will be in the world during the cinematic. Then you could do that kind of thing. So we're going to keep it focus distance for our purposes. So focus distance here is set for 0, which basically means where the camera is right now will be the focus point. What that means is that you'll never see anything out of focus in the foreground because the foreground is set to 0. So to get that to change, we need to change this value to something that's far away from the camera. For example, let's set the ship up to be the spaceship up to be our center of focus here. Let's go into top view and measure how far away this ship will be. In order to do that, our camera is about right here right now. Ship is about right here. If we middle mouse and drag, we'll get a measurement value. That'll be a good rough estimate for us for our focal distance. So let's just call it 1,000 to make things easy. I'll go back and pick our post-process volume here. Here we got the right one. We're going to go back here and put in, oh, no, that's not the right one. It's this one down here. Let's redo our measurement from the stairs. So that's more like 600. Let's go in here and do focus distance at 600. Now you might notice nothing has changed yet. That's because our focus inner radius is set to 2000. What that means is that out here at 600 where I put the focal point, from that point out in a radius of 2000, there's a big circle being drawn. And everything inside that circle is going to basically be in focus. In order to see this change, we're going to decrease this radius because right now this whole world the whole scene is within 2000. So let's take it down to 200. And let's make sure that we have it enabled. Now we can see a big difference. There's a little tiny circle in our scene that is in focus and the rest is out of focus. Now, one thing to note is that this distance right here is very tight. It goes from being very blurry to being crisp in a short distance. This distance here is the fall off exponent. If you make this exponent bigger, it'll be an even tighter transition. If you make it smaller, then it'll be more gradual. For instance, 1 will be much more of a soft blur, but it will also blur toward your focal point. So you might want to increase your radial distance here, kind of make that a smoother transition. So it goes from out here all the way to here, sort of a really soft feeling in our scene. Now tighten that up if you want it to be really clamped, just for demonstrative purposes. If we do 10 and change this back to a value that's really tight again, it's almost like a hard line right there practically. That's with the high exponent value. But we like 1 because 1 is pretty. So let's leave it 1 and 500 because that looks pretty cool. Now one thing you'll notice is the background and foreground. In the background, it's really blurry and the foreground is pretty blurry. Those can be controlled separately here through max far blur amount and max near blur amount. Far blur amount is currently 1. If you change it to 0, everything in the background turns into focus. If you change the foreground to 0, same thing. Foreground is in focus. If you want the background to just be 0.5, foreground to just be 0.5, you get the idea. So you have control over that. Now blur kernel size is the amount of blur. If you change this to 64, you'll get even softer, more Vaseline style highlights on everything. 16 is default. Last thing is depth of field interpolation duration. And this is for transitioning again between 2 volumes, how quickly you want the depth of field to transition, because sometimes you want the depth of field to transition at a different rate than the overall volume. That goes for bloom and for motion blur as well down here. So that pretty much covers depth of field. Let's talk a little bit about motion blur. Okay, the first thing to note about motion blur is that you can't really preview it here in the viewport. You pretty much have to preview it in play in editor, play from here, or play out of editor using a command line launcher. So let's go ahead and launch it from play in editor. But before we do that, let's set up some of these settings so that they're meaningful here. Let's make motion blur amount 5, and this is the amount of blur overall. And let's set this motion blur camera rotation to a value. Let's see, default is 45. What this value is for when you rotate your camera, how much of an arc of blur are you going to see? The bigger the number, the bigger the arc. And also the more sick your user will feel when he's playing the game. So keep it, it's good to keep it under control. But to try this out, let's just set it for 15, which would be a really tiny arc. And let's go out to our middle volume here and set our shadows and highlights to a little more subtle of a red here so that we can get a little more contrast in our frame so we can see the blur a little better. Now let's go ahead and launch this and see what we get. Now here the blur is strong, but the arc is actually pretty non-noticeable. You can't really see an arcing blur happening much because the value is so little. Let's try increasing it. Go pick our volume again. This time let's set our camera rotation value to 90 and see what we get. Now if you notice, there's a lot more of an angular blur happening here as we move from side to side. Let's go have a look at some more settings for motion blur. Go back to our volume again. Okay, so a couple more things here. There's camera translation threshold as well. And this is a distance that will be the maximum amount of streak that you'll get in distance per second. So translation threshold of 10,000 would mean that you'd have to travel 10,000 world units before the blurring would stop. And in Unreal, 10,000 world units is a long ways. You'd have to be on a rocket ship or something in order to exceed that value. It's a good default value to have. Interpolation duration is also a way to interpolate between volumes. If you wanted one volume to have extreme motion blur and another volume to have almost no motion blur, you could set this duration to be the blend between them. And max velocity is a way to clamp how much blur you're going to get. So if you increase this number, you're going to get more blur. And if you decrease this number, it will allow only a lot less blur to happen in your scene. That's pretty much it for motion blur. Let's move on to ambient occlusion. Let's get back to a location where we can see it really well. Okay, a great way to view your ambient occlusion settings is to turn on lighting only mode, because then it eliminates all your texture noise and you can see what's really happening with ambient occlusion. Let's go ahead and pull up our settings again. And our ambient occlusion flag is up here at the top of our settings. And you'll notice that all we have is one flag. It's on or off. And right now, if I toggle it, nothing will happen because I haven't enabled it in my post-process chain. So let's go back to our chain here, pick our ambient occlusion effect, and ensure that I have use world settings enabled. Now if I go back and toggle this, you can see it turns on and off. Now there are some settings which are available for you in the ambient occlusion effect node, but notice that it's only available here in the chain. You can't set this the settings on this per post-process volume or at your world info node level. You can only do it globally for all of the maps that you're working on in the game. Starting at the top here, let's go over to a good place to preview this. These pipes are a really great place to preview this. Occlusion power is basically how strong your occlusion effect is. You can change this value to C, but a higher the number, the more profuse the effect is. So 50 is pretty huge. 10 is really strong, 4 is default, and it's pretty blotchy in here. You can control the blotchiness by changing this from medium to high. It's smoother. If you change it to low, it's really blotchy, but it'll run faster. Scale also is the amount it's going to bleed. So say 25, 30, 40, 50, 10, 0. Now bias is a way to push the effect a little more, dampen it. You do 30, it goes away. Try 10, it'll still be pretty much gone. You have to keep these values down between 1 and -1 pretty much, but 1 is gone. 0.5 is a little hint of it. 0 is default. -0.5 gets you a little stronger, and -1 gets you pretty strong. So this is another bias setting. You can do minimum occlusion so that you can clamp how little it'll get. Let's leave this one SSAO2. We'll get back to that in a second. Occlusion radius is the distance it's going to do a check per pixel between one point and another point before it's basically how far apart objects need to be or pixels need to be on the screen before it will fill in between them. So if you set this to a very low number, then it'll fill in tight areas but not big open gaps between areas. If you do a bigger number, it'll start to fill in bigger gaps and collect between bigger gaps, which is better for more overcast kind of days and stuff like that. 25 is default. Attenuation is a way to control quality over distance. So the lower the number, the faster you'll go, but the lower the quality. Change this to 10, for instance. It'll include the darks all the way to the back of the room. But if you change this to 50, it'll start to blow some of those out. So it's a good way to control your effect based on distance. Occlusion fade out, min distance and max distance is just how far away from the camera your effect will fade out. It's good to keep it the default numbers for the most part. If you try to make these bigger, then you'll end up with a lot of black lines way off in the distance, and a lot of your distant detail will become obscured by black globbiness. So you want to keep those dialed in a little bit. The halo distance threshold is good for objects which are obscuring each other. For instance, the ground and this board. This board is occluding the ground. So the larger the number, the more samples will happen between objects which are occluding each other. This is similar to, in theory, to occlusion radius, except for it's based off of objects which are occluding each other in the view space. That's why it's called a halo, because it'll leave a dark halo around an object that is going to cover up an object behind it. Distance scale is a way to dampen, and occlusion is another way to dampen. It's the same as occlusion up here. Filter is some settings which can control overall quality. History convergence time is basically a way to smooth and blend between frames. It's good to keep that at default. And that's pretty much it as far as what you can do with all the default native ambient occlusion settings. Now coming back to this last point here, this checkbox stands for Screen Space Ambient Occlusion 2. This is going to basically be the new version of ambient occlusion from Epic. They've already sent out notification on the UDN that they're going to phase out all of these other settings which are here, just to set up a one-size-fits-all ambient occlusion node here using screen space ambient occlusion. The reason for that is because ambient occlusion shouldn't really need to be tuned. There should really pretty much be some ideal settings that everybody can use. And secondly, the screen space version is going to be a lot faster than this current version here. So expect all these settings to go away in a build coming up soon. They didn't say when, but it's probably, if I had to guess, would happen sometime in 2010, probably the first half of 2010. Okay, that's pretty much it for ambient occlusion. Let's go ahead and move on to my favorite node, which is the material post-process node. Okay, to start out with material post-process effects, we have to go back to our post-process chain and ensure that we have a material effect node on our chain. It's good to have it in the middle of the chain. If you don't have it in the middle of the chain, you can sometimes not really see it preview, and it won't show up correctly sometimes in your viewports. All this, the only setting this node really has is this material slot. That's also got use world settings. But this material slot points to a material that you're going to create. Now I've created this basic material for us for the purposes of this tutorial. Let's just start out with something very simple. Just this one node. As you can see, this is a scene texture sample. And this is just a normal material. There's nothing fancy in here at all. It's just a right-click, create material. Just like if you right-click here, say new material. It's not a special material. You just create a scene texture sample, which if you right-click, go to texture, and go to new scene texture, you would get a new scene texture sample node. And all this is it's basically say, take the rendered frame and use it like a texture. And every rendered frame that gets pumped through the renderer, use it like a texture. So the simplest version of a post-process effect using a material post-process effect node is to have this plugged straight into your emissive channel like this. What this will do is basically render the frame and do nothing to it and then just render it. And you do have to have it set up, your material set up with the blend translucent blend mode and unlit lighting model for this to work. If you change this, you'll get an error in your scene. But in order to get this to work, we're going to have to hook it up. So let's go back to this material here, make sure it's selected, and then go back into our material effect node and hit the green button and load it in. And you'll see the warning here. It says it uses a lighting mode other than MLM unlit. So we do want that changed. Just going back and just mentioning what I said before, which is this has to be translucent, this has to be unlit, otherwise it will complain. So as long as you've got that set up, you should be able to go in and start messing with your settings here and seeing a result in the engine. Now, like we said, there's nothing happening to this frame because we haven't told anything to happen to this frame yet. There's just the scene itself. So we're seeing just like what we saw before. Now to change this just a little bit, we can add say multiply, then add a vector parameter to add a color, and we'll multiply the frame by color, just as a simple example of what you can do with scene post-process. We'll make it green. And now you can see the scene is green. Basically, anything that you can do to a texture, you can do to your rendered frame. That's what makes using material post-processing so cool, because you can, anything you could think of, you can pretty much do. So let's go and look at this a little bigger example here. Okay, so in this example, and it's a fairly simple example, we've got a principle of doing what we just did before, which is taking a green and multiplying it by our rendered frame. And from there, I'm desaturating it by a little bit, that rendered frame, and then I'm normally, if I were to plug that straight into my emissive, I would get a certain effect. Example, let's do it. This is the effect of that frame all by itself. Now, if I've also got a backplate on here, which is using red instead, and it's desaturating it a little bit less. If we use that one instead, we'll get this look. Now, I'm using a depth mask between the two, and the depth mask looks like this. Things which are close to the camera are darker, and things which are farther away are brighter. And the way this works is by using this scene depth node right here. Scene depth captures the scene's depth from the point of the camera all the way to the back of the scene. So it can be a pretty big number, so usually you have to divide it by a value. And I usually use between 1,000 and 3,000 to divide my scene depth by. Different numbers will get you a little different spread between dark and light in your scene. And depending on your level and how deep your scene is, you may be looking at a vista, like a far off vista. You may need a different number here for your scene depth to get this mask to look good. From here, I add this value here, which is just a constant, and it's a way to push the gradient, which is created by this division, forward or backward. So this is 0.2 right now. If I were to make this 0, basically what this would be without anything, it pulls it closer, pulls the darks a little bit more into the foreground, and makes a little bit more of an extreme fall off. From there, I use that as a mask between these two foreground and background plates. Just for fun, let's take the desaturation off of both of these plates so we can see what true black and true green and true red look like with a mask. Now you can see everything in the foreground is green and everything in the background is red, and that stays true even if I move through the scene. Everything that was red will become green, and vice versa. So that's a simple example of how you can use a material for doing a cool post-process effect. Let's move on to a couple of fancier examples. Now for this tutorial, I've created a couple of other examples for us to check out here. So let's open back up our post effect node and plug in a new material effect. This one I'm going to use edge detect. This is an example of just a simple edge detection post-process effect, which you can use. And what this does is it uses a simple scene depth render and a pixel shifts it in a direction and then does a subtract so that you can get the edges of everything in the scene based off of the scene depth. This can be really useful for doing effects like toon shading or additive burned edges on things, making things look a little bit more crispy than they normally would be. And let's take a look at the material and see how this thing is put together. This shader is a little bit more complicated than the last one. Starts out with the screen position node here, and what this is doing is just taking the screen's overall positions in coordinates and masking out just X and Y. It gives 4 coordinates, but we're just going to take the first 2. And I provide an offset here, which is 1/10,000th, and actually negative 1/10,000th offset. And through this network here of nodes, I'm just taking these coordinates and creating positive and negative U and V values. And the reason for this is to create 3 vectors, which will shift 3 scene depth grabs. These 3 scene depth grabs are the exact same grab, so if you were to plug in each of these independently without this UV shift plugged into it, they would all look the same. But because they're all being shifted by a small increment, up here when I subtract them from each other, I get a small difference in value, and that's what creates these lines. So after the scene depth setup here, I just put it through a simple divide pass, just like before, by a value. Here is 1500. And then I run it through some clamps to make sure that anything beyond a certain distance away won't be affected by this effect. And that's mainly used for detail way off in the distance and for skyboxes. Because if you have thick lines drawing on top of things really far in the distance, it's really distracting and ugly. So I tend to clip that out at a certain distance. This value can change and will need to be tweaked and updated as a map gets built out. I don't clamp them in on these clamps. Then I just subtract these from each other, grab their absolutes, add them together. At the end, I've got this image. And that's basically essentially how to do an edge detection and just using a material post-process effect. Some fun ways to tweak this effect are to go back to the offset and change this value to, say, negative 0.04, that should quadruple the thickness of our lines. There we go. Let's change this back. Another way would be to change this dampener for the depth value of the gradient spread which exists in the scene to, say, something a lot higher, 5,000 for instance. And what that does is it tightens down the lines, makes them a lot crisper, and makes the lines in the foreground a lot darker. To show you an example, let's go back to 1500. There, it brightens up quite a bit. So that's a fun network to put together. Now let's try the same effect but using the screen instead of using a scene depth. We'll close that down, go back to our node. I'm going to load up this other one I've got for you guys. Now this one has a really unique feeling to it. It's kind of like a Conte crayon or a paint daubs filter in Photoshop. If you look at it up close, you can really start to see some interesting patterns and effects which occur on surfaces. It's almost like the entire image has been drawn in charcoal or colored charcoal. The way this is put together is very similar to the last one. Let's take a look. Similar looking network, same screen position and offset, same vector shifting network as before, except for instead of these new vectors being put into scene depths, they're being put into scene texture samples. So it's taking the rendered frame instead of the scene depth, and it's shifting that by a small amount. And then it's just using those same three and subtracting, grabbing an absolute. I didn't have to do any of the depth sampling or any of the divisions that I had to do in the last shader graph because I'm not sampling depth anymore. And that's all you need to be able to get this kind of an effect. Some fun settings to tweak on something like this. Again, basically it's the offset. Try a larger number and hit OK and see what we get. You get a lot more blur. Quite a lot more noisy. Not quite as pretty. And again, there it is. This concludes our post-process effects tutorial in Unreal Engine 3. I hope you guys have had fun and have a lot of fun playing with these post-process effects. They're a real blast. And special thanks to E3D for putting this on. Thank you. Greetings, I'm Dave Prout, and this E3D tutorial is an exhaustive look at lighting in Epic's UDK. For this demo, we'll be using the March 2010 build available from Epic, as well as the Necropolis map, which it comes with. Now, getting great looking lighting to perform at great frame rates is always a core challenge in graphics pipelines, and over the past 5 years, Unreal Engine 3 has done a lot of experimentation with lighting models and workflows in an attempt to maximize the quality and performance of the engine. And just the sheer amount of experimentation that Epic's done in the engine over the last 5 years can make it pretty difficult to learn lighting, since there's a lot of legacy lighting techniques that are maintained in the engine for developers that still use them. So in learning lighting in Unreal, it's worthwhile to run through a brief history of these models to better understand what each one of them does and what came along next to improve on it. Let's begin by having a look at this small demonstration map that I put together for you. Lights in Unreal are pretty much like you can find in any 3D package. You've got your basics, which is spotlights here. You got direct light, directional light here, which is a parallel light, like the sun. You got a skylight. It's called a skylight, but it's an ambient light. It's the same thing. And there's point lights as well. These are the four fundamental light types that all the other light types are derivative from in Unreal. And you can find them by opening up your content browser and going to your Actor Classes tab. Find the light rollout here, and you'll see all these types. There's directional light, point light, skylight, and spotlight. And in order to place them in your scene, you just pick one, you right-click, you say Add Directional Light here, or this is a context-sensitive menu, so anything that you add, if you're familiar with the engine already, you already know about all this stuff. But I just wanted to point it out for anybody who needed a refresher. Underneath each of these types, directional light, point light, skylight, spotlight, there's different subtypes, and these tend to be more expensive versions of the parent type. But there's toggleable, and there's dominant. Dominant is for using light mask. It's the latest version of the lights in Unreal. There's movable and toggleable, which were types which are have been around for a long time in the engine. But toggleable allows you to turn a light on or off over time, and it tends to be more dynamic in nature, and so it's more expensive to render. But if you needed a light to turn on or off based off of a gameplay event, then you'd want to use toggleable. If you wanted the light to move, like for a headlamp or something on a vehicle, you want to use a point light movable or a spotlight movable light, so that you can move it over time. You can also turn those on and off as well, but those are the most expensive kinds, and they're the most dynamic, and they're calculated per frame. So avoid using them if you don't absolutely need those types. Moving on, let's close this down. Probably the best place to see all of the rich history of the different lighting modes and models that Epic has created is to go into any light and hit F4 to get to its properties. And you can see remnants of everything right here in this rollout. And we'll just start from the earliest days, what was available in lights. Actually, the earliest days is not even available in the interface anymore, but there used to be a way to link objects with lights and lights with objects, just like you can in Maya or in Max, where you've got a per object to light linking system. In Max, there's the exclusion list and an inclusion list. In Maya, there's the light linker, or the relationship manager. This was just a relationship linker from object to light, and it got pretty unwieldy to use, so they replaced that in I think late 2005 or mid 2005 with a new system. And you can't find the linking anymore because it really was not a viable solution at all. So they actually deprecated it. But it was replaced with this concept of light channels. If you find in any light the light bar here, unroll that and scroll down, you'll find a rollout called lighting channels. This is what came next to do light organization. And inside lighting channels, this started out in the Gears development under Gears of War 1, and there weren't as many of these channels as there are now. There's probably half this many, or almost half this many. And it's basically just a way for you to set up associations between a light and an object. And by default, when you create a light or you create a static mesh or any object, some of these flags are flagged by default. You can see BSP is default, composite dynamic is default, and static is default. We'll get into what composite dynamic means in a little bit, but just know that if it's in, say, the static channel, which is pretty much one of the main default channels to have objects inside of, then it will get lit according to whatever else is in the static channel. So this object here, this cone that I've created, it also, if you go to the static mesh actor and roll down, you'll see lighting inside static mesh actor, and then inside there's lighting channels. And inside lighting channels, you'll see the same lighting channels as you see for lights. This enables you to dial in, it's a light linking system. It enables you to dial in relationships between lights and objects. So this object belongs to static, this light belongs to static, therefore this light affects this object. You notice there's a lot of different channels here, and most of the time they're not all used. So they're just set up there for in case you need them. But there are a lot set up for cinematics, because a lot of times during cinematic work in real-time games and real-time movies in Engine, there are lots of lights turning on and off, and lots of objects which are affected, and special shots which you have to set up the lighting very carefully for. And there's rim lights and key lights and fill lights, and you need the control that this offers. So that's why there's so many different channels here. Now gameplay, those are just for gameplay. Unnamed are just for miscellaneous, whatever you want to set up. Skybox pretty much never gets used. As far as I know, nobody uses Skybox, because typically Skyboxes are handled with emissive materials, so they don't generally get lit unless you've got like storms or something happening with lightning and they need to light the clouds up. And even then, a lot of times that's just all timed through the material using emissive textures. So lights are not typically used in Skybox. I wouldn't say that they're never used, but most of the time they're not. And that's pretty much it. Now, there are some things which we ran into on one of the games I was working on, where if you try to change the defaults here and say, for instance, turn off the static in code so that the static is no longer a default flag that gets set, you can break some other things underlying in the code. So it's if you're just new to using Unreal, I wouldn't recommend going and messing with the default settings for these channels. I just recommend using the unnamed ones, or using some other ones that aren't being used. These ones with enumerations on the end tend to be the only thing which truly makes these different is the name. They're functionally all identical, so you could use any of them and it'd be fine. The ones that I would stay away from using in a kind of a custom way are static, dynamic, composite dynamic, and BSP. Now, static mesh, you'll see, doesn't have the same flag set as in light by default. It only has static flagged here. The light, on the other hand, has static plus composite dynamic plus BSP flagged. So that's typically what you get when you first set up a light. So to demonstrate this really quick, if I take this light and take it out of static, so it no longer participates in the static channel, and then I rebake, I should note here, I'm actually, for the first part of this tutorial, I'm going to leave use light mask turned off, because we're not going to use light mask at the beginning. I'm walking you through the standard lights first here. Hit OK. And there's no more green light on anything which is in the static channel, which is all of these meshes are static meshes. So there's no more green light hitting any of these because I turned it off. Now, let's say I wanted just this cone to be lit by this green light. What I can do is tell this cone to belong to unnamed 2, for instance, and then tell this green light to belong to unnamed 2. And you can already see the previews happening there, but if I bake, there you have it. And it's really good to know about these flags, because the bake times can be dramatically decreased while maintaining the same quality if you control these relationships. If everything belongs to the static channel, then every light has to be calculated against every static mesh, and it takes a long time. But if you can set up associations so that you know, for instance, if you were to pretend that each one of these is its own room, and that these black spaces in between were walls, I left them open for this case just so you can see the light bleeding, and that the lights won't bleed, because even though they should bleed because there's no walls, they won't bleed here because the way that I have it set up with the linking. So let's set up these associations really quickly and go in here to my static meshes and make sure these are just a part of unnamed 2. I'm going to set up my 2 lights, make sure those are part of unnamed 2. And take them off of static. I'm going to do the same thing here. This time I'm going to put it in unnamed 3, because I want to treat it as if it's its own separate room. Pick its lights. and same here. Unnamed 4. One more thing I should note here, I do have these other two lights, which I'm going to get to in a second, and they're currently turned off, so they're not actually affecting the scene at all right now. Now if I bake, you can already kind of see it in the preview, but if I bake, there's no more bleeding between these three fake rooms. There's no green light hitting this surface, there's no purple or orange light hitting the green surface, whereas before they were all mixing across these boundaries. That's one way to set up light linking relationships. That pretty much covers lighting channels. Now the next way to set up exclusive relationships, and this was done about the same time as light channels, it's at the end of 2005, early 2006, is through a flag called Effect Only, Same, and Specified. It's kind of a long name for a flag, but in any case, if you go back to your light, and it's only in lights, you scroll down past the lighting channel section, there's this flag called Only Effect Same and Specified Levels. And the way this works is your light currently exists inside of a level, a sub-level. You can find out which levels it's located inside of here. If you open up this Levels tab, and you right-click on your light, and you say select Level, and then select Make Current Level. That will highlight the level here in your Levels section where this light exists. So any objects within this light's level, it will light. For example, if I were to take this light now, as an example, and go back and select all my lights, you just select all lights of any type. I'm going to turn off all their custom flags that I had set up for their channels. There we go. I'm going to go back to, notice how they all went dark. Go back to my static meshes here. Put them also back into the static channel. Now, if I rebake, they should all be remixing again. There we have it. I'll note that I'm in lighting only view mode here, so that I can ignore the textures that I might happen to have on these surfaces and just look at the lighting itself. And you can see the bleeding is happening again here with green touching the purple and corner of the purple hitting here, etc., etc. So anyways, to set up a lighting level exclusive relationship, I've set up the cone room here in its own level. I've also set up the torus in its own level and the oil tank in its own level. This is the torus and the oil tank here. And inside each one of these sublevels are 4 actors. There's the spot, the point light, the back wall and floor, and then the object itself. Each one set in a sublevel. The way this works with the lights is you go and you set the flag for select effect only, same as specified. And if you don't add any other levels to effect here right underneath, then it will only affect the level that light is currently a part of. If you can always add more levels here by just saying add new item, and you can add, say, the one right next to it, right here in my scene, or any other level you might have in your scenes. But this is another way to do exclusivity. So even though before I had it set up and green was bleeding over to purple, now that I have this flag selected on these 2 lights, if we rebake, you'll notice the green is no longer penetrating over to the purple. But the purple is penetrating back over to the green because I have the purple, the green, and this blue, or the orange and the blue set up to penetrate or to not be exclusive to its own level. So that's another way to control lighting. That can be useful for interiors with really bright lights, like emergency rooms or emergency light flashing and stuff like that. It's a way to just make sure that you're controlling the number of actor relationships every light has. And that's another way just to, again, to control the amount of time it takes to do a light build. One more thing to mention here. You go to the Levels tab. There's another way to do this, what I just did, but in a different way, is to right-click on any level. You go down here to this flag, Self-Contained Lighting. This will mean that only the lights within that level will affect that level, and the lights within that level will not affect any other levels, kind of like sealing off that level's lighting from the rest of the world. So if we try this now, it should be on the torus sublevel. And notice that the purple light and the yellow light are not affecting this piece here. I should point out that this flag here is rarely used because there's rarely a situation where you truly want a hard seal between two spaces. You almost always want some kind of lighting to blend between one space and the next, because there's always some way for you to travel it from one space that you're in into the next space. I think the only way that I would ever see this being used in production is probably a space that you couldn't get to. Like, for instance, if you're underwater in an underwater area, like in BioShock or something, and outside underwater it's all blue and everything, and inside it's not really got the same light properties. You might use this to light the underwater outdoor section or something. That's pretty much the only time I'd ever see that happen, is when you have physical boundaries that prevent the player from traveling between spaces. But there it is, just in case you want to play with it. Now, as I mentioned before, all of these steps were taken by Epic to try to contain the number of light object interactions, because that's really what was slowing down the engine during development of Gears of War. And they kept having a hard time even after this. They were still getting too many light object interactions. Basically, what it comes down to is the number of dynamic lights per object. Then it really started to affect performance when it came to characters or anything that was moving in the environment. They needed to invent another thing in order to make this the number of associations drop even more. And that's this thing called a light environment. That's not really a manual association that you can do between a light and a set of objects like you can here with channels and stuff. But there is a way to do it, and it was basically what enabled Gears of War 1 to ship. So it's important to know about, because most of the games that I'm aware of that were pre-Gears of War using Unreal Engine 3, they needed this technology in order to be able to hit the frame rate they needed to hit in order to ship on the Xbox or on the PS3. So let's show it to you real quickly. There's this flag here in a light channel called Composite Dynamic. And this is set up by default for any of these lights that you put in the scene. You pretty much always want to have that on, unless you've got a special situation where you're going to want stencil shadows on some things. One important component about composite dynamic lighting is that it uses modulated shadows. And a modulated shadow type is a cheap, fast shadow type, but there are limitations to it. And once we get to the shadow portion of this tutorial, I'll cover that in more depth. But remember that composite dynamic will always use a modulated shadow. The other thing to note here is this flag, Cast Composite Shadow. And this is what works with the composite dynamic flag here in a light environment. Now, the concept of a light environment is sort of theoretical, but it's basically an association that you can set between lights and objects. But for dynamic objects, like characters or anything that moves in the world, you have a special section in your properties here, which, let's see if we can find one here to drop in real quick for you. Okay. We look at the properties for this flag. there's this rollout called light environment, which you won't find in a static mesh actors flag, but you'll find it in any dynamic actors flag. And this light environment has to be enabled, which it will be by default. But if you ever notice that any of your dynamic actors are not being lit correctly and you're planning to use a light environment, make sure you just have this flag enabled on it. And it's separate from the channels themselves. The channels are back down here in lighting, so it's easy to miss and forget, especially if it's 2 o'clock in the morning and you've been working and grinding and crunching for a lot of days. So just remember that it's there. Now, the overall concept of a light environment is, like I said, an association, and the way that it works is it takes any number of lights. It can be hundreds of lights, and if they're all part of the light environment, they'll all be calculated into the light environment. What it means and how it works is each dynamic object gets 2 lights. It gets a spotlight, which is a proxy spotlight, which gets created by the code in the engine. And it's the ambient light for the character. And also I think there's a rim light as well. The rim and the main spotlight, the key light for characters or any other objects, is an average, it's a proxy, and it's an average of all the lights that are surrounding, that you've placed in the scene. And it will average all of their brightness and their shadow vectors, so the directions that the light's coming from and their overall color and brightness. And it will create a proxy light for each dynamic object to ensure that each dynamic object only gets lit by the minimum number of lights possible. And that's the way that they were able to control performance for gears. It's a pretty ingenious way of doing it, and I've shipped a couple of titles using it, and I recommend it. Try this out, this concept out. Let's convert this cone to a mover, which makes it a dynamic object. If we convert it then to a K actor, it converts it to literally a physics actor. And if you look at its properties now, you will have a dynamic SM actor, static mesh actor, and you'll have a light environment rollout. It is enabled because it's enabled by default because it's a smart system to use. So make sure that we've got our light channels enabled here for composite dynamic. I believe that if you've got this flag enabled here, then it will work down below as well. So if we turn on lighting here, this is being lit by the light environment right now. So it's as you move it around, you notice that it's getting shadowed appropriately. And if we bake, give the nice crisp shadow on the back. Now if we take this thing out of the composite dynamic family here in the light environment, you notice that it went black because it no longer subscribes to the static environment because it's a dynamic object. This is the kind of thing that can happen if you don't have your characters or your dynamic objects set up to receive lighting correctly. They can drive you nuts too. So just keep it in mind. You want to keep it enabled. So for us, we'll just convert it back to a static mesh here. Make our lives a little bit simpler. Alrighty. Now there are 2 more ways to handle exclusivity and relationships between lights and objects that happen around the same time as these features. So we'll cover those here. Go back into lighting only mode so I can show you. The next method I'm going to explain here is a light effects classification setting. It's another way to set relationships between lights and objects. You notice each of these spotlights has an S on it, and each of these point lights has an S on it. And this directional light in the back has a U on it. That is due to, if you right click on any of these lights and you say set what this light affects, and there's these 3 options. There's dynamic objects, static objects, and both dynamic and static objects. These are all set up right now just with S because they are only affecting static objects, which is one of the reasons why our cone went dark a second ago. If we look at the settings here, you can see this right here, light effects classification, LAC static affecting. So What this really does is when you click on it and you change this setting, what it's really doing under the hood is it's changing some of these channels. If we right click on this one, for instance, and say affects both dynamic and static, see if you notice here, it enabled the dynamic, disabled the composite dynamic on this light. It also changes the setting here to LAC dynamic and static affecting. If you go back in here to any of these and start messing with some of these shadow settings, you'll get a U because it's saying, okay, it's user defined now. It's different from a preset. It's something the user has created. So to quickly change it so you don't have to remember every single box you have checked and all this, just to set it up for static objects, you just go back and say set with the slide effects static, and it'll reset everything back to normal, how it expects it to be. It's actually U still. I think that's because I've got this shadows off default. You can always tell when the text is bold that it's not default. So now it's back to S again. Now the last way we're going to talk about associations and exclusivity is through light volumes. And just like any other volume in Unreal, you can go and create a BSP brush. Create this. You can create a light volume. And we're just going to create one really quickly here. Let's do something tricky with this association. Let's make it so that only this green, actually only this green and red light will affect what's inside this box and not the actual orange and purple lights. Move them really close so that they will bleed in, but not put them inside the box. Now we can select this brush and right click down here in the Add Volume button and say Light Volume. Now if we turn off our builder brush, we've got a light volume here. And for this volume, it's just a plain volume. If we wanted to set up the volumes here, it's per light. If you click your light you want, here we've clicked our green light, go down to, there's a flag here called Use Volumes. Where is it? There it is. Use Volumes, right here. And if we scroll back up here, we can see inclusion volumes and exclusion volumes. If we wanted to add this to our inclusion volume list, the way we do that is having this light selected, you actually have to go and lock it. And that keeps this this window here reflecting this light's settings even if you click off of it. So it's still, you can see the green bar here, still, even though I've clicked and selected this volume now, this hasn't changed over. Still's got it here in for the spotlight. Now it'll let us go through and add a new volume, and then we can add this light volume right here to our included volumes list, and that will work. Now we can unlock and then go and pick our red light and do the same thing. We've got to make sure that we check our box for use volumes. And go back up to inclusion volumes here, lock it. And there we've got two that are using the light volumes here. Now if we go and we delete these two lights, we delete these two lights, make sure we got a really clean view here, and we bake. Okay, now just to wrap up, we covered lighting channels, effect only, same and specified, and we covered self-contained lighting, light effects classification, light volumes. These are all ways to control exclusivity between lights and objects, and managed well, they'll help your performance and they'll improve your bake times quite a bit. Now let's move on to some light parameters. Now for the next segment, we're going to go through these light settings and go in detail into what each of these settings does and how it works. One of the first things I'd like to cover, which is just a pet peeve of mine, is sometimes when you're working on a scene and it's this far away, you can't really pick any of the lights because they're so tiny. And sometimes there's lights which you're tinkering with all the time, and it's really difficult and frustrating because you can't pick it. So it would be a lot easier if some of these icons were bigger. One way you can do that is pick any of these lights. Like for instance, the skylight is one that you're going to be touching a lot. So it'd be nice if the icon was bigger. If you go to its properties and you go to display here and this draw scale value and change this to something bigger, then you'll get a bigger icon. It'll make it a lot easier to select later on. Make your life a lot simpler. That's one thing to note. You can do that with any light. And a lot of times with big scenes, if I've got, say, for instance, the sun, and I'm this far away from it, I might even make it, 50. So I can really see it. And I'd have no problem there. So there you go. So let's get into each of these types. The skylight, let's start with this. Skylight is something which is not used in light mass anymore. It's not recommended really by Epic to use in light mass. You can still use it in light mass, but light mass uses radiosity and it uses bounced light. So there's much less of a need for a skylight in your map artistically. But you can add it if you want artistically. And there shouldn't necessarily be a functional reason why you'd need to add it. For instance, the player should be able to see everywhere where they're walking, just with the dominant light in their scene using light mass. But a skylight, like I said before, is an ambient light. It functions just like an ambient light, and a lot of the skylight's values are the same as in other lights. There are shadow values here, which are not really useful for skylight because skylight by nature doesn't cast shadows. It's used to basically set the darkest point, your dark point for your whole scene. It's the way that I think of it when I use ambient lights. By default, it's white and it's pretty bright. So, but you can see here if I turn it on, it really brightens up everything in my scene by a certain amount. It goes right into all the shadows and all the darks and just blasts them out. So that's there. Anything that any vector-based information here about shadows or composite dynamic shadow direction, these values are not really used in the engine for skylights. Skylights are pretty basic. They do adhere to light channels, so you can use those. And that's pretty much it. You can set a color and a value. Next, let's look at directional lights. Here we'll get down into some details on what each light is and how the shadowing works. First thing to note here is trace distance. By default in Unreal, trace distance is set to 100,000. Now this is a really big distance. Almost no levels. I'd say I'd never seen a level in Unreal that's 100,000 units across. Most levels that I see are more like 10,000 or 15,000 units across. So it's worthwhile to set this value to a lot smaller number, because if you keep it at the default, it's just going to slow down your light bake. I recommend setting this at like 10,000 to 5 or even 5,000 most of the time. Unless your sun is way up in the sky and it's shooting on a giant level, you're never going to need it to be 100,000. And your light bakes times will improve if you shrink it down. In light component here, we're going to skip over directional light component because this has mostly to do with using dominant directional lights, which we're not going to talk about quite yet until we get to light mass. So light component here, affect composite shadow direction. This means composite shadow always refers to composite dynamic and light environments, like we were just talking about. So this will influence the vector of the light if you have this checked. It will include the vector from this light in its overall average of the proxy light that gets generated per character or per dynamic object. Usually you want that to be enabled unless your brightness value is really, really low. In which case it'll be averaged accordingly anyways and weighted according to its brightness. So it's almost never a time when you don't just want that checked. So keep that checked. There's also can affect primitives outside dynamic channel right here. This is an exception flag for objects which are dynamic but are not inside the dynamic channel down in the lighting channels here. Like I said before, there's a lot of exceptions built in over the years for different rule sets for all the different lighting modes, and this is a flag which will enable lighting to happen in even though you don't have dynamic checked here, which I guess there would be some edge cases for that. Can cast composite shadow. This is a composite shadow. This is not just the direction of the composite shadow, but it's actually included in the composite shadow visually as well, not just in the direction. Usually you want to keep that on if you're using it in composite dynamic light environment. Casting, these three here are very important. Casting dynamic shadows, cast shadows, and cast static shadows. This is a little bit ambiguous the way this is set out here. Cast shadows actually controls these other two. So it's basically like a parent setting for dynamic and static. So if you want dynamic or static to work, you need to have cast shadows checked. If you have this turned off, but you still have these two checked, then you won't get shadows because this parent one is not checked. Sort of a redundant flag, but it's been in there since I can ever remember. So it's just something to keep in mind. Now, the difference between dynamic shadows and static shadows are static shadows are baked, and they're either baked using a light map or a shadow map, which we'll talk about in a little bit what the differences between those are, versus a dynamic shadow, which is a shadow which is calculated per frame. It's stencil based, or it's a shadow buffer shadow, or modulated, and this enables or disables those. Be enabled, like I said before, is basically an on and off switch for the light. Exclusion volumes and inclusion volumes we've covered. Force dynamic light, this checkbox here, just don't ever check it. It forces the light to become the most expensive stencil shadow light that is possible in the engine. And the only case you'd ever want to check it is if you're doing a still frame shot of something that you've done. And it's for like a marketing piece or a portfolio piece, and you don't really care about frame rate at all. And then you could use that. But if you're running around inside of a map, I just don't recommend checking that box because it'll run too slow for you. Light color is pretty self-explanatory. Pick your color of your light. And light environment, bounced light brightness. So light environments include a little bit of a bounced light. This enables you to set a separate color for that. So if you wanted it to always be green, you could always have your bounced light be green. Light shadow mode, there's normal, and then there's modulate and modulate better. And normal is expensive shadows. Modulate is a shadow which is multiplied on top of everything else in the scene, which is a shadow which is cast from dynamic objects. So it's a dynamic light type. Usually this is what you want to have unless you're using light mass. Normal is more expensive and uses some of the older code, and modulate better is just an optimized version of modulate. So I just recommend using the defaults. Lighting channels we've gone through. Min and max shadow resolution. This is for shadow maps, not for light maps. And it sets basically the shadow resolution per light. I should probably take a break here to talk a little bit about the difference between a shadow map and a light map. They get confused a lot. A shadow map is basically a map which is assigned to a light. A shadow map is always assigned to a light. It's projected from a light out onto the scene, and it's usually pre-calculated. So it's kind of like a template or a gel or a mask on top of a light to tell the light where it should illuminate and where it should shadow. In contrast, a light map is per object. The light maps themselves are stored per map, and you can find them after baking by looking in your package list and finding the package that has the same name as your map. And you can look inside of that map, that package name, and you can see all the light maps which get baked out. A light map is a texture which is multiplied over top of an object's shader in the renderer, and it's pre-calculated and it doesn't ever move. And you can set those resolutions per object, and we'll get into that in a little bit. but the difference is pretty important. And shadow mapped lights are expensive because they're calculated typically per light per frame, and they're dynamic. They tend to be dynamic, so it's better to use light maps if you can help it. And by default now in the engine, objects are started out using light maps now that they've got sign distance field shadows built into light mass. So back to our properties here. We've got modulated shadow color, so you can control the color of your shadows here. Fade out time and exponent. This is the distance away the camera is from an object's modulated shadow before it will actually render that shadow. So objects which are far away, usually you don't want to spend the resources to draw them because you can't see them anyways when they're far away. So this is the distance away using an exponent distance. And there's a time also, so that usually it's the time that's the shadow is off the screen. Non-modulated self-shadowing is a way for self-shadowing on, say, a character's face. If you enable this, you'll get a higher quality shadow on your character than a normal modulated shadow would be. Modulated shadows are a little grainy looking. So if you're trying to deal with something really subtle like a face or some organic shapes, usually you want to have this enabled. We've already done these other two here, so let's jump to self-shadow only. Self-shadow only is for a light to just do self-shadowing and no cast shadowing off of an object, or all objects which it affects actually. Shadow fade resolution is a threshold in texels that you can use as a minimum for when the shadow should start fading out. Sort of another way to do the min-max shadow resolution and also the shadow fade out exponent and time. That's another way to do it. Shadow filter quality, this is just low, medium, and high. And shadow projection techniques, there's all these different algorithms here in this drop-down. And PCF is in the INI file, it is the default. So if you select default, you're really selecting PCF. And PCF is pretty much the highest quality setting. I've had really bad luck with all these other ones. They're so low that you just never want to use them. And they don't give you enough performance benefit to really matter. So I recommend using PCF or default because that is PCF. Now use direct light map. Using direct light map forces the light to be stored. This light which you have selected forces its information to be stored as a light map instead of as a shadow map. This is good to have checked for performance, for good performance, and usually you want to have this checked by default. Use volumes we've covered already also. And here's a light mask section which we'll get into a little later on. Those are all the settings available in a directional light. Let's jump over and see what's different here in a spot. They're pretty much all the same actually. There's the only thing that's really different is trace distance in the directional light, but we'll just run through real quick and I'll just show you. The one thing which is different here is there's a point light component and a spotlight component setting, which enables you to control some basic things based off of a point. This being a point, then this is being a parallel light, and directional light is a parallel light. The point light component is fall off exponent. This is how quickly your light will fade to darkness, and the higher the value, the quicker the fade. So if you choose 1, it'll have a nice slow fall off, and you choose 10, it'll really clamp that fall off down to be pretty constrained. Min shadow fall off radius is a tuning value. It's not that useful, and I've never used it, but it's a way that you can set shadows to stop occurring really close to the light source. If you want it to be like further away, shadows to start happening further away, you can set this to a higher value. Here's radius of the light itself, and here's the shadow fall off exponent, which is just for shadows, not for the light. And shadow radius multiplier is another tuning value per object. Each object has a bounding sphere, which it uses to calculate the shadow radius from, and this is a multiplier for that bounding sphere. It's all just very low-level tuning values that are not used very often. And spotlight component just controls the cone angles. Here you can see this real thin, brighter blue line here is the 0 value. Like if I spin this up a little bit,
Now let's put in a value of 20. There, now you can see that's the inner cone, and here's the outer cone. If you're familiar with cones and penumbras and fall-offs from any 3D package, then you'll know what that stuff is. And that's it for spotlights. Let's look at points real quick. Points have everything that spots do, except for they don't have the spotlight component section at the bottom. So one thing I should note about using the standard lighting is that the engine uses these lights as a point. It considers these lights to be a point in space. Light mass is different, and we'll get into that in a little bit, but every shadow which gets generated from one of these lights comes as if the spot or the point light is an infinitely small point in space. So you'll always get a sharp point cone on these. Now let's try using some of these settings in a practical way so you can see how they work. Okay, so to demonstrate the difference between regular shadowing and composite dynamic shadowing and lighting, I've set up this sample map here. And on the left, we'll have an idling character here, and on the right we'll have one also. The right-hand side is using composite dynamic lighting, and the left side is not. Otherwise, they're pretty much identical. I've got some cycling lights here, same exact setup on both sides, and we'll be able to cycle through these lights and check them out. In order to set this up, what I did is I flagged each of these lights on this right-hand side here. If you look at their settings, all their composite flags are set for composite shadow and for effect composite shadow direction. And I've got composite dynamic enabled here on those lights. On this opposite side over here, I've turned off the composite flags and just enabled the dynamic flags all the way down. And as well on these characters, on this character which is not being lit by the light environment, I went down and disabled its light environment flag under the skeletal mesh actor. Right here, light environment component. And I've disabled the enabled flag here for light environment component. So let's go ahead and jump in and see what this looks like in game. Here we are. Got some cycling lights. You can see this one on the left here is a regular soldier. If you specifically watch his shadow that's being cast on the ground, you'll see that he gets shadowed from 4 different lights. There's a white light coming from over here. It's cast on him, and that causes the shadow in the back. As each light comes on, he gets a new shadow in respect of the color that's being cast on him. You can see the red here lingering behind. And on his body, you see 4 different shadows appearing, 4 different light sources. And contrast that to the composite dynamic character. You can see, so it's a heavy, dark, multiplicative shadow on top of everything. It's lots darker and more noticeable than the standard shadow guy. But he only has one shadow, and it's a composite from all of the different light sources. And as the light sources turn on and off, it gets its vector gets shifted, and its color gets shifted and blended between all the different light sources. So there's that. Now let's move on to a demo where I can show you some differences between shadow types and quality. Okay, let's have a look at shadow quality and shadow type a little more closely. Here I've got a scene that I've created that's got 3 different segments in it, using light volumes to make the effect of the lights exclusive to the area that I would like just here on these planes. I've got similar setup in terms of geometry on each of these 3. Got a static mesh torus knot on all 3. I've got a BSP ground plane and a BSP wall plane. And I've got a skeletal mesh soldier here on all 3 as well. So having a little closer look at shadows, we can see there's these 2 cases here.
The only real difference is in shadow quality, shadow type between these two. Both of these are using dynamic shadows. They're not using composite dynamic shadows. Dynamic shadows are more expensive than composite dynamic shadows, as we mentioned earlier. And you can actually see that if you go into light complexity. Black means it's the fastest it will run. It will be very fast to run. Green means it's being hit, like a pure green like this means it's being hit by one directional light, or one dynamic light. And the closer you get to red, the more red gets mixed into your green. The more number of dynamic lights is affecting your object. So in this case, it's getting a little more kind of olive colored than this here. This is probably 2 dynamic lights affecting both of the ground plane on the BSP as well as the soldier robot. So you can see that this composite dynamic one on the far edge here is the cheapest, and this next one over here in the middle is the middle in terms of cheapness, because the soldier is being rendered with only a single dynamic light, whereas the soldier here is being rendered with 2. Let's go back into lighting only mode, and we'll have a look and see how this is set up. First, let's have a closer look at the quality of these shadows. You can see the edges are a little bit blurry. That's due to the shadow quality. And these shadows are set up as properties of these lights here. So let's have a look. Right here, I'm using the light shadow mode of normal. This is what is causing this shadow to be so blue. This is in contrast to this light here, which is using modulate, and that's what causes this shadow to be a different color and slightly lighter and brighter than the other one. And both of these lights, if I select both, are identical in every other way. None of them are using any composite flags. So starting at the top here, I'm going to roll up just the light. Both affect composite shadow direction is off, cast composite shadow is off, and then I turned on cast dynamic shadows and enabled that. And here I've just got my inclusion volumes, which I'm using to separate out the scene and create exclusivity. Light shadow mode has got multiple values. This is because this one's using modulate and this one is using normal. And as we move down, composite dynamic is disabled, dynamic is enabled. And if you go all the way down to the bottom here, we've got shadow filter quality of low, and we've got the production technique as default, which is PCF, which is this one here. Now I have use direct light map disabled also on these, and it's worth going into a little bit of detail here. Use direct light map forces a light's shadow properties to, when enabled, it forces the shadows to be baked into the object's light maps. It's a way to ensure that performance is as clean and cheap as possible. If this is enabled, that will be true. And I mentioned before, you can actually find and see your light maps and shadow maps as they're baked out. So here, I'll show you how to find those. If you look in your UT game folder, content, and there's this maps folder here. And whenever you create a new map, I've got a package in this maps folder under the same name. So in this case, there's DP Proxies 3. And inside this package are all my light and shadow maps that got baked last time I baked my scene. So you can see here, shadow maps. Shadow maps, again, are tied to lights. So the lights themselves here are projecting through these shadow maps to onto the scene to create shadows. But contrast, a light map is attached to static meshes and BSPs. Anything which is static in the scene usually gets a light map. And the reason why you only want static objects is because it's the light map doesn't change over time. It's baked into it's as if you painted it into the texture. So it doesn't ever move. It doesn't ever change. And you most of the time in games, 90% of the scene is using a light map because for performance reasons, it makes more sense. But you can go in here and poke around and see, this looks like it's the torus knot, the 3 torus knots actually, right here all being lit with light maps, because I have light maps set up for those 3 torus knots. And you can see these little pools of light here on this shadow map and also on this light map. There's 2 here that are shadow map and a third one here which is light mapped. That's because I've got shadow maps on these first 2 and then a light map on this last one. So that's how you can find those maps. And going back to our scene here, you can see the difference also on the characters. You see a lot of character self-shadowing here that's very dark because of the kind of shadows that are being used on this object here. If you were to go and look in this skeleton mesh, I've also disabled light environment for this skeleton mesh because I didn't want to use it. I wanted to use dynamic lighting. And the skeleton mesh also has forced direct light map disabled. Now, forced direct light map on an object basis functions similarly to use direct light map on a light basis. So in the light, it forces the object to receive its light as a light map. If you select this flag on an object, it forces the object to use a light map. It's just another way of doing the same thing but on an object basis. But since this is a moving object, I don't want it to use a light map because I don't want the shadows to be baked right onto the surface of it. So if we move over to this next one, see the quality of the light here is a lot brighter, just like on the ground here, because of the kind of shadow that's being cast from the light on this object. And its self-shadowing is a lot brighter. You notice on both of these, the quality of this penumbra is really good. It's just nice and smooth. There's no artifacts in it at all. And this is a quality difference between using a pure directional or dynamic light and using a composite dynamic light. If you move over to this third one, you can see a lot more artifact happening in the shadow with a composite dynamic light. But you'll notice that it looks really good as far as the shadow goes itself. It incorporates the color, whereas these two don't do as good a job at that. Here it's really black, and here it's washed out. And the cast shadow as well looks really good. At least as good as over here with the dynamic light. Now, if you just look at purely in lighting mode, you might go, well, there's so much artifacting in this, I just don't know if I want to use it. But if you turn it on and look at it in lit with textures mode, you really can't tell a difference. If you look pretty close, I mean, there's really no way to see it because the materials really cover it up. So it's just something to keep in mind. Now let's see it in motion and see what it looks like. So you can see this is a normal, non-composite dynamic light shadow being cast. Just a pure dynamic shadow. Here is a modulated shadow on a dynamic light without composite dynamic enabled. And here is a straight up composite dynamic light. And as I said before, this is the cheapest. And there you have it. All right, this next segment we're going to be talking about doing some light mapping. And your scene, if you've started one up, it might end up looking like this at the start. You've got some materials and some objects in it, but the lighting doesn't look very good, and it doesn't seem like it makes a lot of sense. And you want to know how to make it go from this to something which looks pretty good. And so we'll do that with this little set of objects here. There's some things that you need to know about light mapping, in that it operates differently depending on the type of surface that you're using. A static mesh, such as this torus or this cage here, set of bars, these are static meshes, and their light mapping is done a little differently than BSP planes, which is this back wall and this ground plane. Well, let's start out with this BSP plane because it's the simplest. If you right-click on any BSP plane and go to Surface Properties, you'll see that it has quite a few different settings here for controlling the UV tiling and panning of the texture, and the rotation of the texture, and the scaling of the texture. And here there's a lighting section, and there's this light map resolution. Now this number is a little bit deceptive because it operates inversely from the way it would happen on a static mesh. What I mean by that is, by default, you'll see 32 as being pretty common default for the light map resolution on BSPs. And you might think that you want to increase this to something like 512, because that's what you'd want to do on a static mesh in order to get more resolution. But it's the opposite with a BSP. You want to go down. So say 4. 4 is good. If you go down below 4, you're going to get subdivided down to 2 and then 1. And 1 is basically 16 times more dense than 4. And you can see that when the math works out. But make sure that you really need 1, because it's going to take you a lot longer to compute the light map for that surface than 4. You can go on any surface and change its light map resolution. And if you want, you can also, for BSPs, just go and select, all surfaces. Select surfaces, select all surfaces. That'll give you all the BSP surfaces in the scene, and you can change them all at once. What I like to do is, I know the planes where I want light, and so I put those to something like 4 or maybe less. Maybe something like less in this case is in the inverse, of course. So I might go to 8, I might go to 16. And then I select the inverse. And with the inverse, I would actually change this number to like 4096, which is basically like a pixel or half a pixel for each one of these other faces, because I don't want any lighting information on those, and so I don't want to have to waste my time during light baking waiting for these sides of the BSP to bake, because they're never going to get any light anyways. And from there, if you were to go in and rebake this file, you get much better results on the surface. Now I picked an object like this grade here just so that we could play with how dense the light map needs to be. But you can see that 4 is a lot better than 32 already. Let's go ahead and make this 1. See what it looks like. There we go. There we have a really as crisp as you're going to get on a BSP with a light map. And if you turn on materials, a lot of those artifacts will pretty much go away. It might show up if you have a very, very clean material, but for the most part, you won't notice them. So that's how it works with BSPs. You'll notice that this torus is all messed up still, and we're not getting a very good shadow from this grate on this torus. So let's have a look at static meshes and how light maps work on those. So if we go to this torus, and I'm going to go up out of your view here and select Find in Content Browser. I'm just going to bring it over to and select it for me in my content browser. And open it up. There we go. Some things to note about this torus. Light map coordinate index and light map resolution are relevant values for us right now. Over here it says UV channels 1. What this means is this torus was brought in with only one UV set. And if you look at, you can look at that UV set by selecting coordinate index 0 and then going and clicking on this show UV overlay button, and you'll see all the UVs laid out here. And the way that this torus was UV mapped, it was in a linear breaking UV bounds. So you're seeing literally layers and layers and layers over top of each other because it's just showing it in 0 to 1 space. But it's actually a giant strip of polygons as long as the length of this torus is. And so it's not very good for doing light mapping because there's a lot of overlapping polygons and stuff. And you're going to get a bad light map if you try to use this UV set as your light map. So what we want to do is in order to get a good light map, we need to create a second UV set. And there are a couple ways of doing that. And until kind of recently, you had to do that in in your content creation package, either in Max or in Maya, and then you had to import it into Static Mesh Editor, and you could change it from there. But fairly recently, Epic has added a UV cruncher for you. So let's do that real quick and add a second UV set right here in the editor on this torus. You go to Mesh, you say Generate Unique UVs. You want to generate unique UVs for 0, for LOD 0, because I don't have any other LODs. It's just this base mesh here. And I want to save my UV channel results to channel 1, not 0, because 0 is where I have my diffuse map and my normal map, and that's where my shader is working. And I want a different UV space for my light map than I do for my shader. So let's save it out to UV set 1. And one thing to note about static meshes in Unreal is you can have up to 2 UV channels per static mesh. And in code, you can actually increase that. You can make that, I think 3, I think is the most I've ever seen on a game team. And that was changed under the hood by engineers. But there was also lots of trouble with it, but it changed some of the content pipeline to make sure that it worked. But in any case, there's 2 by default. So we're going to use the second one in this case, because the first one is 0 and the second one is 1. We're just going to select 1. Now our generation method, we're going to do limit stretching 0 to 1, and we can also say limit the maximum number of charts, which is basically clusters of polygons. So you can control it that way instead if you'd like. I've found that this one works really well. I'm really happy with the algorithm they use to do their UV layouts in this package, and I use it all the time. So I'm just going to use the defaults here. And from there, you just have to go and hit up the apply button, and you'll get a second UV set for your mesh. Okay. Now we can see that there's 2 UV channels here, and we can close down this Generate Unique UVs dialog. We're going to tell our light map coordinate index to use 1 instead of 0. What that will mean was when you actually go to bake and build lighting, it will use this second UV set instead of the first one. And you can also look at what it did by just going back to the UV layout view, and with that 1 selected, you can see that it broke it up into some really nice kind of pelting planes. And it did a great job. Now the light map resolution is pretty small right now. And like we mentioned before, inverse to BSP, this is actually more intuitive. You can increase this up to, I think, 1024. It's limited in the INI file how big it will actually get. You can, even if you typed in 10,000, it would be clamped at a maximum size in the INI file. But for our cases, let's just make it 256 and close this down. And we'll just bake this one object. You can see the previous information has been removed because the object's been updated. Let's do only selected static meshes. And there we go. That's much better. In fact, it's almost the same visual resolution as what's on the BSP. Matches pretty well. And we're going to do the same thing here with this cage. I'm going to open this up. Actually, we go to Find in Content Browser. There it is. This one also only has 1 light map coordinate index. This one actually has unique layouts for the material, so you could use the same one here for your light map because every polygon has unique UV space. You can try it out. Let's just go ahead and try it out and see what happens here. We'll use 0 and set our resolution to 256 for this one also, and bake this one. That doesn't look bad. For fun, you could always go back and create a second UV set as well. Keep in mind that when you do create second UV sets on meshes, it increases your vertex count on your meshes. And that's because for every new UV that gets created, it's got to create a new normal, vertex normal. And it breaks your mesh up, the stripping in your mesh up. So your memory will go up for every UV set that you add. So just keep that in mind. Now if we look at this in lit mode, we can just do a fresh bake on the whole scene, and that way it'll clean out all the light maps and create new ones across the whole scene. Now you can start to see a pretty clean, much cleaner anyways than we had at the start, lighting build. You can notice this is not happening here. That's because I set the light map resolution here to 1, and I have not updated this one to be 1 also. So if we do that, try once more. Now what just happened, I just sped up the video for you guys so you didn't have to wait for all that time, but it took a significantly longer amount of time to bake that 1 resolution than it did the 4. So just again, keep that in mind. And there you have light mapping and how to set up good light maps for your meshes in Unreal. Now let's wrap this up with some work on light mass. According to Epic, light mass is the new state of the art for their engine, and it's really, really cool. It's important to have started out with the basics that we've already covered in order to understand where light mass came from and how it works. But it's still built on top of light maps and shadow maps, and it has some new features in it which enable really a lot cleaner, smoother, nicer looking results. Light mass is a radiosity or bounce light generation utility, and it's a new way to render things. The way to turn it on, I will show you in a minute. So let's do, for the sake of comparison here, I've created a little scene with the wall in between 2 lights, and this is using standard lighting. There's no light mass happening in this scene. There's a yellow light here and a really hard edge. Notice this hard edge here on the wall, and then a blue light over here. And that's pretty much it. Let's go ahead and see what happens if we use light mass instead. Now, I'm not using, for those of you who have heard of light mass and know some of the features of it, I'm not using any dominant lights in the scene yet. These are all just using the standard lights, and these are using 2 point lights. If I open up the properties for the point lights, and go down to the section on light mass here. And what this is allows you to set some values just for light mass. There's indirect lighting saturation, indirect lighting scale, and light source radius. This is really important. We'll cover in a sec. And shadow exponent, which is the fall off, just like in shadow exponent up above in the main light settings. So in order to enable light mass, you need to go to World Properties and go down to Use Global Illumination in your world. And once that's turned on, you should be able to see when you click on a light, like here, I've clicked on this light, I have this new yellow radius, inner radius. And there's one on this lamp too. It's just, maybe I'm not have it flagged to be visible. Yeah, I just needed to be refreshed there. So 128. There's a big distinction between light mass and regular lights. As I said before, earlier in the tutorial, these lights normally are considered to be points in space, infinitely small points in space. And all the light which comes from the lamp is coming from this point in space. Light mass changes this idea. Actually, it uses this whole yellow sphere as a light source. What that means is you're not going to get a single sharp edge like this on a shadow if your light source is this big. It means that rays are coming off of this side of the sphere, and off of this side of the sphere. So let's go ahead and calculate this, and I'll show you what it looks like visually, what the difference looks like. One thing that you'll notice is that Unreal Swarm Agent will start to appear, and will start to calculate your lighting for you. And it does a pass where it emits photons and then collects photons, and then it processes the maps, which is what's happening right now. I went ahead and skipped through the progress bar there for you guys. Now you'll see this is being lit by light mass. And you see the quality of this shadow is much different than before. And it's not the hard edge. It's also really subtle. And if you look at it in lighting only mode, you can see it's actually a little bit more artifacted than you'd notice with materials on. But it looks quite a bit better, and it bounces a lot better around the room here. You can see it hitting even the ceiling up above. So one thing to show you here is that because this sphere is actually a big surface area light, you can put it in between or penetrating through an object, and it will actually shine on both sides of that object. So let me go ahead and build lighting again here, and then I'll show you guys the result. There we have it. Now you can see there's actually light penetrating on both sides of this wall, even though it's one light. One thing I need to point out also is when you go to build lighting, you have to make sure that use light mass is checked in order for light mass to work. Otherwise it won't. And probably the last thing I'll show you as far as the lighting process goes for light mass is that you're now not limited only to lights. You can use objects as light sources. Any object, any mesh with a material on it can be a light source. So I'm going to show you what that looks like here. I've got a couple of different torus knots. I've got a blue one and a red one. And I'll show you what this looks like when it's baked as well. One thing I need to point out, let me delete these other two lights. We can just see purely what it looks like when you don't have anything in it, any lights in it. I'm going to look up and look at static mesh actor properties, which is just above your screen here in the menu. Go down to use emissive for static lighting. And this will enable the material, the emissive channel into the material that you have applied to your mesh to emit light. Let's go ahead and bake this and see what happens. Here we go. Now you can see we've got red emissive coming from this torus knot and blue emissive coming from this other torus knot, which is interpenetrating the wall in the back. And it's bouncing around the room. They're both pretty bright. I have their emissives set up. Let me show you. To be double bright. So this red here is 2, not 1. And the white is a 2222, so it's double brightness, and I'm using a Fresnel to create this halo around the edges of the object. And there's one more thing to show you here, and that's if you go to properties again, you can actually amplify the amount of light by doing an emissive boost right here, changing this value to a higher number than 1. And here are some more influences and fall-off exponents, just like in any other light that you might have. Now let's have a look at light mass in a large scene, and I'll show you what is called sign distance field shadows. Here we are. This is the Necropolis map that's given with as a part of UDK, and you can see it's a really beautiful map. This version is a truncated version that I created just for this demo. I removed a lot of the geometry so that it'll be easier to move around inside of. But let's go ahead and have a closer look at some of these shadows. We come over here and turn on lighting only mode and have a look at what's going on here. This shadow is very clean compared to what you'd normally expect from any shadows that are normally baked out using normal lighting process. Even here, this shadow which just cuts right across the scene is very clean. And the reason for that is because Epic has switched over to using sign distance field shadows. And to explain better what those are, I've pulled up the original white paper here that Valve published back in 2007 at SIGGRAPH. And this is the way that it works. It takes a typical texture, 64 by 64 texture. This is with the normal alpha testing, using the algorithm they have here in the white paper. And you can read it in more detail if you want to know how it works a little better. But this is that same 64 by 64 texture here, but it's using they've taken this first step of doing alpha testing, and then they do an algorithm to straighten out the lines here. And they get this super crisp texture, which you can zoom in all the way on, and it'll remain crisp no matter how close you get to it. This is a technique which they pioneered at Valve. And Epic, in their UDN on the Unreal Developers Network, they do cite that they took the technique from Valve, which Valve published here in the white paper so that other people could use it. And the first game I think they ever used it on, just for the sake of trivia, was Team Fortress 2. You might see some of these signs as you're running around inside Team Fortress 2. But it enables you to use a little tiny texture, very small and very blurry, to create a really crisp looking texture. And so the way that Epic implemented this in lighting is to use this in shadows for shadow maps, which is a really smart thing to do. Because what this does is enables super crisp shadows for almost no cost. 64 by 64 texture is tiny. So with this, when they did this, they actually shifted from using vertex colors by default. Before they implemented this technique here, sign distance field shadows, everything was vertex color lit by default, and you had to manually change that to use a light map. And now that they have sign distance field shadows, that's what the default is for everything. When you first import a static mesh, the default is now to have a light map associated with it, because they're assuming that you're going to be using this technique. And there's a good reason for that, because it's so awesome. You can even see some of these cast shadow details. Well, if you look up at the shape of this ridge here, it's very bumpy. Down here it's a little bit more jagged, but that's just because it's using the algorithm for sign distance field shadows. And you can get far away, you can get very close, and they stay relatively crisp. It's just an excellent use of the technology that Valve came up with, and I'm really glad they put it here in the UDK for us to use. Now, one last thing I need to touch on is this volume here. This is called, look down here, a light mass importance volume. If we go ahead and look at this in top view. It's actually enclosing the entire environment. And as I said before, if you open up this map in your version of the UDK, you'll see a lot more geometry than what I have here, because I've deleted some so that I can move around the scene a little faster. But this volume, this light mass importance volume, that is around all this geometry here, is here so that it reduces the amount of calculations that the light mass job will take in calculating everything in the map. It's highly recommended that you stick to as small a volume as you can, because it will basically create higher resolution inside that volume than outside that volume. If you don't have a volume in your scene, then it will assume that you want your entire scene to be enclosed inside of a volume, and it will be the maximum amount of time it will take to bake. And light mask takes a lot longer to bake than normal lighting, unless you've got a render farm or a machine with lots of cores on it that can handle the load concurrently. So just keep that in mind. Put that around anything that you want to have light mask rendering on to keep it crisp, and keep it as small as you can to contain the objects that you really care about. And you'll save yourself a lot of time in rendering. This scene here, just for a point of reference, took my computer, which is a Dell 700. It's not the latest and greatest technology, but it's a dual core. And it took it about an hour to bake the light mass onto this environment. Well, this comes to the end of the tutorial. I hope that you've enjoyed it, and thanks to E3D for allowing me to put it on, and thank you for watching. Now let's have a look at light functions. As you can see here, light functions are often used to create clouds moving over the surface of the terrain,
They can also be used to cast shadows, such as fans spinning, or you can shine colors through them, like stained glass windows. Now let me show you how we put this kind of thing together. Here I have the dominant directional light. One thing that I should mention is that dominant directional lights, they perform much better with light functions than regular directional lights. According to Epic, these lights can, because of the way they're calculated, they only cost about 1 millisecond, which is 1/30th of a 30 frames per second game, to calculate a shot just like what I just shown you here. And a regular directional light without light mask costs quite a bit more. It's more like 1 millisecond overall for overhead, and then another 1.5 milliseconds per light that's using the function. So it can add up to, say, 2.5 minimum milliseconds for your light. Let's go ahead and look at the properties for this dominant directional light. Let me scroll down to lighting here. There's this roll up that will normally not be bolded. It's normally just plain text like the rest of these here. But I have one added here, which is the clouds moving. So there's this rollout called function. And let me just clear it and re-add it so you guys can see how this works. Normally it looks like this. In order to add one, you need to go to this little blue arrow, say create a new object, light function. And then you unroll this thing, and it's got source material slot, and it's got a scale, a multiplier here. And I actually had those previous clouds set to 4096. That just scales the bitmap up that you're going to be using, or the material up that you're going to be using. And I have a source material, which I'll show you here. They're very simple to set up. Go over here and open mine up. It's this moving clouds one. And it's just a simple, I went into Photoshop and I did a clouds filter. And then I did, this is a 1024 texture, by the way, clouds filter. Then I did another clouds filter on top, and I multiplied it over top of the original clouds filter. And this is what I got. Nice thing about cloud filters is that they automatically tile left to right and top to bottom. And I stuck a panner on it so it moves, and just did a speed of 0.1, both X and Y. Moves a little fast in the scene right now, but it helps you guys see it quicker, so easily tuned. That needs to be plugged into the emissive slot on a material. And there's nothing else plugged in, just the emissive. And if you look at the material, there's one checkbox you've got to check down here, used as light function. Got to check that. Once you have that all set up, you can pick it, and then you can plug it right in, and you're good to go. Just bake your lighting, and you'll have clouds moving in your scene, and that's how you set up a light function.
My name is Jim Magill, and I would like to welcome you to Eat3D's latest Unreal Development Kit training video, an introduction to Lightmass. Lightmass is Epic's new lighting solution, and is meant to work as a replacement to the lighting method that shipped with previous versions of the Unreal Editor. The old method still works the same as before, so if you prefer it or if it suits your particular needs better, it's there for you. This is an introduction to Lightmass, so today I won't be covering some of the advanced options, nor will I discuss in detail every possible configuration. I will cover the Lightmass settings that will get you there quickest. In other words, if you incorporate the tips and settings that I demonstrate in this video into your own workflow, you should have no problem getting great results with Lightmass in no time. So let's get started. The scene I chose for this video is one I made for a personal portfolio project. So for the purposes of this video, I opened that map, selected all of the static meshes, I copied them with Control-C or Edit Copy. Then I opened a new scene in the UDK and I pasted them in. So what we're looking at here is a clean scene with no lights and all default UDK scene properties. Now if we go into lit mode by clicking this icon, we see a completely black scene. The only thing visible are the actors that have emissive materials assigned to them. We have the sky, the ceiling light source, some emissive elements underneath the ship wings, and then I've placed these tiny green emissive spheres as additional light sources. So the first thing I do whenever I start a new scene in Unreal is I save a camera. I do that so that I can take screenshots from a fixed position and monitor my progress. The way to do that is to position your camera wherever you want it, then hit Control 1 through 0 at the top of your keyboard. So you can save 10 cameras with each Unreal scene. So position your camera, hit Control 1, move your camera anywhere in the scene, and then hit 1 again and it'll return to your saved camera. Okay, so next we're going to make sure that light mask is enabled for our scene. To do that, we'll go to View, World Properties, Light Mask, and make sure this box is checked next to Global Illumination. If that box is checked, it means that this scene will use light mask. If it's unchecked, it means that this scene will use Unreal's old method of lighting. Now that we've enabled light mask in our scene, I'd like to talk a little about light mask importance volumes. What these volumes do for you is they allow you to focus your lighting detail in the areas of your scene that need it the most. Without these volumes, your entire level would get the same lighting detail, which would lead to really long bake times. So what you do is you place these volumes where your scene really needs that lighting detail, and this will speed up your lighting bake times by quite a bit. So for our tiny little scene, it's not that critical, but I'm going to go ahead and make one so that you can see how it's done. So in order to add one of these volumes to our scene, first we need to locate our builder brush. Now I know that mine is hidden, so I'm going to unhide it by going to the viewport options drop-down, show, builder brush, or you can see you can also just hit B. So now that that's visible, I'm going to select it, then go to the top viewport to edit it. To switch viewports, go back to this drop-down, viewport type, top. So with that selected, I'm going to go into geometry mode, and then I'm going to hold down Control and Alt and click drag a box to select this brush's control points. With those selected, we'll move them into place. Now we're going to go into the front view, viewport type, front, and continue editing our brush until it encompasses our scene. Once I've done that, I'm going to go back to my camera mode and back to perspective view. And then with this brush selected, I'm going to right click this button and go down and select Light Mask Importance Volume. So now when we drag away our builder brush, we see that the volume we created remains. If you select it, you should see Light Mask Importance Volume at the bottom of your screen. Okay, for our first light mask test, what I would like to do is attempt to light this entire scene, this room, with just one of these emissive spheres. So I'm going to duplicate one temporarily by holding Alt and dragging. I'm going to move it to the center of the room, about, and I'm going to open up its properties by hitting F4. If you go to its light mask properties, light mask settings, at the bottom you'll see use emissive for static lighting. We're going to turn that on. I'll come back to the rest of these settings in a bit. So with that turned on, close this. I'm going to go back to our saved camera by hitting 1. And I'm going to deselect that sphere by hitting escape. Now that we have our temporary light source set up to work with light masks, we're going to build lighting. So to do that, we're going to click this light bulb icon at the top, and that brings up the lighting build options. So these are the defaults. Use light mask is already set. Build BSP, we don't have any, but it's okay for it to be turned on. And build static meshes. And the build quality is set to preview, which means quick build, quicker anyway, but it won't be as accurate. And we'll get to these other settings later. So click OK. Okay, this is the Swarm Agent status window. Whether you're building your lighting locally or connected to a network, this window provides useful info during what can be really long build times. Personally, I love this window simply because it displays lighting completion percentages. To see this, click on the Log tab to monitor your progress and time left in the build. Okay, now that our lighting is baked, let's go into lit mode and see what we got. Now, obviously this isn't the look we're going for, but this test has shown the power of light mass. I mean, we were able to light this entire scene with the emissive light from this tiny sphere. Pretty amazing. Now's a good time to go over some of the new lighting reports. These would be located under View, Lighting Info. The first one is Lighting Results. And we see that it's complaining that RublePile 01 has overlapping UVs. So you can select it in the list here. Luckily there's only one. Click Go To, and it's going to take you to that static mesh in the content browser. So we can double click it there. And click this button to show UV overlay. It's not obvious where that overlap is. That doesn't mean it's not there. It's definitely there. I would just have to investigate it further in Max to find out what the problem is. So that's very useful. We're going to ignore it for now. The next new report is back under View, Lighting Info, Lighting Build Info. And what's cool about this one is it's telling me that, well, you can sort. Let's sort it first. Okay, so this one's on top. It's telling me that this actor is taking up almost 10% of the total lighting time of that long build time. This is the major culprit. So we can select it and click Go To. Let me close this, get it out of the way. And I know what it's going to be. It's the floor. And the reason it takes so long is because I'm going to hit F4 and go to Properties, Static Mesh Actor, Component, the bottom Static Mesh Component. Its light map is set to 1024. And I'm not going to change it because it looks good and that's the way I want it, but I'm paying the price for it. That thing is, it's increasing my lighting times by quite a bit. Okay, hit Escape, deselect that. Guess I should go to unlit mode and get rid of that green. That's getting annoying. And the final report I wanted to talk to you about is back under View, Lighting Info, Lighting Static Mesh Info. So I'm going to rescan all levels. And what this is telling us is, well, first off, it's listing every static mesh actor in the scene. And under current type, that's telling you whether it's lit with a light map or vertex lit. So what's really cool is you can select these and change them here within this window without going back to the browser or going to the actor properties. I don't want to do it because I guess it doesn't matter if it breaks lighting. So what you can do is where it says vertex, select those, set to texture. Bam, it changes it. Set it back to vertex. Or you can swap. Same thing. We'll click these, texture, hit swap, swaps to vertex, lit mode. That simple. Very cool tools. And again, these are just the highlights. There are many more useful tools and features hidden within these windows. Okay, let's start building our lighting from the ground up. First thing I want to do is delete this temporary light source from our test, unless we want everything to be green. I know that I want the emissive, these ship wings, to contribute to the overall lighting, so let's start with them. I'm going to select both of those guys and hit F4. Go back into their light mass properties. And as we did before in the tests, I'm just going to turn on use emissive for static lighting. Go with the defaults and we'll see what we get. Okay, let's see what sort of results we achieved with the emissive ship wings as the only source of light. Go back to lit mode. After our test with the green emissive spheres, This is pretty much what I expected. Notice the even lighting throughout the room. Have the smooth fall off outward from the light's origin. Also notice how the light is less intense on the side of the ship that's partially buried in rubble, and then more intense, as you would expect, on the left side, which is completely exposed. I think our next step will be to turn these green emissive spheres on and see how they blend in with this light coming from the ship's wings. So then our next step will be to add light from the green emissives to the light coming from the ship wings. To do that, I'm going to select all of the spheres. So I'll select one, right click, select actors, select matching static meshes. You can see at the bottom of the screen we have two selected. That's the two on the ship, the one here, and then the one at the base of this wing. And to turn that on, same story. F4 for properties, light mass, and enable it. I'm going to go with the defaults again. Now I think what's going to happen is, especially with two of these spheres now, the green is just going to overtake the whole scene. But maybe it'll look cool. So let's bake it and see what we got. Yeah, this is interesting, but it's nowhere near the subtlety I'm looking for. We are getting that blend between the colors, but it's just, the green is just too strong at this point. So let's go back to properties for an adjustment. F4 again. So I'm going to knock the emissive down just a bit, the emissive boost from 1 to 0.8 on both of them. Escape, deselect. I realize that this small change sounds kind of like I'm shooting in the dark, but anyone that's worked with baked lighting understands that this is the process. Pick a setting, bake lighting for results, repeat until you're satisfied with it, pretty much. Okay, this is closer, but still not where I want it to be. Check out the soft blend between the orange and the green light. Here on the walls, back in these openings, soft blends between the colors. It looks really nice. Then this side, on the other hand, is still a little much. So then rather than another adjustment at the actor level, let's take a look at the material properties for these green spheres. So they both use the same. Let's make sure that there's not a material override. Make sure that we're making adjustments to the right material. So click one, hit F4, static mesh actor, go down to rendering, materials, and there's nothing here. If it had an override on it, it would be here. So whatever is assigned to this mesh at the package level, that's the material that we need to adjust. So I'm going to right click, find in content browser. Here we go. Double click this guy, go to LOD info, and open this all the way out. And material, or next to the material, I'm going to hit the magnifying glass to jump to that material in the browser. Double click to open the material. And here on the bottom, in these properties towards the bottom here, there's light mass settings. So you'll see that we have a few of the same options, but they're at the material level. So the changes made here will affect everything that has this material assigned to it. So let's take the boost down by half. Take it down to 0.5. Why not? Let's see what happens. We'll save this material by clicking this green check. Just to be safe, go ahead and save the package and close this browser. So we'll bake and give that a shot. Okay, now it's too subtle. That material adjustment we made was pretty heavy-handed, but now we'll make one final adjustment at the actor level, and hopefully we can move on. Back to light mass, where we had set the emissive boost to 0.8. I'm going to put that back at 1. These settings are pretty touchy, so hopefully that'll be enough. The other one, which is doing nothing, I don't know. Let's try 4. Okay, so what I ended up doing was I set the emissive boost on the material to 0.75. 0.5 was just way too subtle and I couldn't do anything with it. So you'll see here, we've got going on this side is a tighter influence radius from this emissive sphere. You can see that it doesn't light the entire wall anymore. It's a nice fall off, short fall off. That's what I was hoping for. This side is still a little too subtle now. I'd like to get more from this emissive sphere, but I'm going to wait and adjust that after we get more of our light sources in. It doesn't make a lot of sense to worry too much about it at this point, because as we bring in our other light sources, these settings will likely need to be adjusted again anyway. So don't worry too much if you can't get each light source to look perfect on its own. I adjust these settings in stages because to attempt to adjust all light sources at once would be insane, as you can imagine. So at the end of the day, it's about the total lighting effect and how everything comes together. We're off to a pretty good start though. Next up, we're going to tackle these ceiling lights. See what they bring to the mix. Okay, next up, let's take a look at these ceiling lights. Now, even though we have settings that work pretty well with the wing and the green sphere emissives, we can't just apply those settings to these ceiling lights. Each of these emissive materials at their base levels have different emissive intensities, which come from the material settings and the textures. All we can really do is try out a setting that seems reasonable at the time, bake it, adjust it, repeat, and so on. So let's go ahead and select one of these lights. These lights, by the way, ship with UDK. I found this by, let me show you real quick. Open up the content browser. Content here, I have force loaded or fully loaded all of content. And up here it says type to search in this field. I typed light. And then here in the object type, I just wanted to look at static meshes. There we go. So I placed it and scaled it. Easy enough. So I'm going to right click, select actors, matching static meshes this class. We have 8 in the scene. Just like before, I'm going to hit F4. Go down to light mass. Cross our fingers and try out the defaults. Use emissive for static lighting is checked. I'm going to bake it and then I will be back. What we're looking at here is a screenshot of the baked lighting before the ceiling lights were turned on and after. As you can see, those little guys really lit up the room with the default settings. So the emissive material must have been pretty high. It's okay though. I think I want to make one slight adjustment to them back in the editor, and we'll call those lights done and move on to something else. Right click, select actors, select matching. F4. I want to crank up the emissive boost a little bit. Remember how touchy these settings are. 1.2 on that. And I want to give it a softer fall off. I'm going to double that, go from 2 to 4. Should be good. We'll move on, see what this looks like. Okay, here's another quick screenshot comparison. This is the lighting before we made that latest slight change to the ceiling lights and after. Not a huge difference, I know. But if you notice this back wall, keep your eye there. You can see how the light is pooling a little better. There's more separation between the pools of light. It's not a huge deal now, but I think that when we bake at the higher quality settings later, it'll be more evident. I'd like to remind you at this point that we still don't have any Unreal light actors in the scene. All lighting is originating from these emissive materials. I'd also like to say that we're still using the preview quality level when we're baking our lights. This gives us a decent representation of what lighting will look like at higher quality levels, and it bakes much quicker. I think we can call those ceiling lights done and move on to something else now. Okay, what I want to do next is I want to add a spotlight to our scene so that we can start attempting to simulate sunlight coming through the hole in the roof. Before I do that, I want to create a new level and import it as a submap into our persistent level here, just so that we can keep our scene somewhat organized. To do that, I'm going to click this button here to open up the content browser again, but I'm going to go over to Level Manager, go to Current, click Level, New Level, and I'm going to name it. So it's in this folder. The only thing here is our capture underscore P. The P is for persistent. So our new map name is going to be underscore lights, I guess. Click Save. Going to ask you what streaming method. For our purposes, we don't care. We'll say Kismet. That's fine. There we go. Let's save everything. So now whenever you load up our main persistent, it's going to bring in this referenced submap. Okay, now that we've added our new light level as a submap, let's add our spotlight to it. To do that, we're going to double click to make it current. And so now anything that we drop from the content browser, anything we add, anything we duplicate from within the maps is going to go to this level because it's current. You go back and make the persistent level current simply by double clicking. So with our lights level current, we're going to go to actor classes. Under light, on here you'll see spotlight. Just click that, get this out of the way. And then anywhere here in the level, I'm going to right click and add spotlight here. It's that easy. Now that we have our spotlight placed in the scene, let's move it to where we want it and then talk about some of the settings. So the idea is that this is the beginning of our lighting simulation for sunlight coming through this hole in the roof. I'm just hitting spacebar to click between the transform modes. Okay, let's talk about settings for our new spotlight. Before we do that, I want to clear away some of this debris, some of this junk from the screen, just to give us some of our screen space back for this part of the video. I'm going to select actors, select matching. I'm going to click this closed eye to hide. I'm going to control click some of this other stuff and hide it. It's good enough. I'm going to select our spotlight, hit F4 for properties, go to light, light component. I'll probably drag this over some. Okay, starting with light component, we have the brightness of the light, self-explanatory. So this is supposed to simulate our sun somewhat, so I want to start with something fairly bright. So let's go with 5. Not too crazy. And then the light color down here. I'm going to go with something something yellow and exaggerated to simulate our sunlight. I'm going to click this magnifying glass to go to this color picker, and I have a yellow sunlight color already saved in my custom colors, so I'm just going to go with that. Click OK. And I think that's it. That's all we need to cover in the light component, the brightness and the light color. We'll jump down. We'll skip light mask for this for right now. We'll go down to point light component. In the fall off exponent, larger fall offs give us a softer lighting effect. So I'm going to bump that up, go to 5. You can see the changes down here in real time as I make adjustments to these settings. In the radius, I want to make sure that it reaches the floor. So let me come out some, see what we got. So it's at 1024 now. Okay, so at 500, 1000, 1500. Okay, that'll work. You see that it lit up the rubble on the floor when I went from, so 1024 is the default. And I'm bumping that up to 1500. So we make sure that it reaches the floor. That's the radius. And fall off exponent radius, that's it for the point light component. We get to the spotlight component. And what we care about here is the outer cone angle. So what we want is something wide. We want it to affect a large part of the room, which is pretty wide now. I mean, it's pretty much doing what we want it to. May bump it up some. It's at 44. Let's try 50. Yeah, either way. 44, 50. The default would have worked fine. 50 sounds better, so let's go with that. And let's jump into the light mask settings for the spotlight. So the indirect lighting saturation. Okay, first off, whenever they say indirect lighting, just think bounce lighting. Same thing. Indirect is bounce. So for our bounce lighting saturation, we're going to leave it at 1. If you set that at 0, then that would mean that as this light bounced around, it would lose its saturation entirely. It would go straight to a white light. We're going to leave it the same, so it'll continue with the color that we specified when we created the light as it bounces around the room. So the indirect lighting scale, think of this as the bounce lighting scale. And we don't want to be the bounce to be as bright as the direct light. So we'll go with something low on that. So as it bounces around the room, it's not going to be as bright as the direct light, as its initial lighting intensity. So with that, we're going to go with something low. Let's try 0.1. And then the light source radius is the other thing we're going to focus on. The larger the number, the softer the lighting is going to be. So the default is 32. I've played with this already a little bit, and I'm going to go with a really large number of 400. When in doubt, you can always mouse over these settings. The tooltips will give you a little hint about what these settings do. So the light source radius is the radius of the light's emissive surface, not the light's influence. There you go. So let's save this and bake it and see what it does for us. So here's another quick screenshot comparison. This is before our spotlight was added and after. Now I know that this new light isn't anywhere near intense enough to represent our sun, but I have the remedy for that. Coming up next. In order to get that intense sunlight effect, I'm going to add a dominant directional light to the scene. Before I do, I want to give it its own map too. So just like before, I'm going to click this icon to go to the content browser, go over to Level Manager, Level, New Level, and I'm going to name it Sunlight. Kismet is fine. Save the persistent, make the sunlight current, go to Actor Classes, Light, Directional Light, and Dominant Directional Light. Right click, add Dominant Directional Light here, and let's move it into position. So it comes in pointing straight down. What I want to do is go to our main camera by pressing 1. And I'm going to adjust it from here. Just going to rotate it around until I get the dramatic effect I'm looking for. We want it to cut across the stairs and not come all the way out to the edge of the image. That's good for now. So let's go to its properties, F4, light component. For the brightness, let's crank it and see what it looks like. Let's try 4. Okay, let's try 2. Okay, for now we want a little bit of blown out hot spots here. Maybe that's still too much. Let's go with that for now. And the light color, I'm going to pick that same saved sunlight color that we used with the spotlight. Then under light mass settings, these are the same settings. The spotlight. The saturation, let's leave that alone. Indirect lighting scale, let's lower that to 0.2 so that the bounce lighting won't be as intense as the direct light. And we'll bake it and see what we have. Now that lighting is baked, let's see what our dominant directional light is doing for us. See, now that's more like it. With what the slide is bringing to our scene, it's much easier to believe that this space is being lit primarily by sunlight and the bounce light it produces. It's looking pretty nice. Yeah, our lighting so far is looking pretty good, I think. Okay, let's enable ambient occlusion for light mass. To do this, we'll go to View, World Properties, Light Mass, Settings, and check this checkbox. That's it, nothing else to it. So not to be confused with the post-process real-time ambient occlusion, this checkbox will turn on the light mass ambient occlusion that will simulate during the lighting bake. So let's try it out. Let's take a look at some screenshots. One without light mass ambient occlusion enabled, and now with it enabled. It's a pretty big difference. Take a look at where my cursor is. This is a good example of what it's doing for us. Without, with. Now remember, our bake is still set to the lowest quality level so that we can iterate quickly. We won't completely see the benefits of this setting until we start baking at the production quality level a little later. Let's talk about one more light mask setting, Indirect Normal Influence Boost. What this does is, it boosts the influence of normal maps in areas where they're lit only by bounce lighting. To enable it, or to change its setting rather, we'll go back to View, World Properties, Light Mask Settings, and we're going to change it from 0.3 to 0.8. So let me bake that, and then I'll show you comparison screenshots. Okay, this is before and after. Before, after. The effect is subtle, but you can definitely see that it's punching up the normal, the walls, the floor, even in the ship wing here in the background. Not a huge difference, but it adds a little. It's not hurting anything to have it on. If you're interested in the quality settings and how they differ, take a look at the images located in the Lighting Quality Setting folder. In this folder are 3 separate camera folders with screenshots from each quality level for comparison. Also, if you open the text file, you'll see that I've listed the time it took to bake lights with each quality setting. You'll see the times range from 7 minutes for the preview level, all the way to almost an hour for the production quality level. Okay, I think it's about time we added some fog to our scene. So to do that, we'll go back to our content browser, go to Actor Classes, and it's under Info, Height Fog. So select that. We can close this window. Somewhere over here out of the way, going to right click, add Height Fog here. Then we'll go to its properties. So F4. One cool trick is to use this Lock Selected Actors button on the properties window. We can turn that on, lock it, and then deselect our actor, and its properties windows will stay. Then if you select something else, it'll bring up its properties when you hit F4 in a new window. It's kind of cool. Use that all the time. Oops, but if you hit Escape to deselect all, you lose it. I don't know why. So just click somewhere out in space to deselect, or use your edit, select none. Okay, so we'll go back to our main camera. Alright, looks pretty good. You can toggle fog by hitting F. So let's take a look at the height fog properties. Looks pretty good. One thing for sure we want to change is the color. So if we go to our color picker here, I want to go with something that's close to our sunlight. So what I have saved here is a darker version of that sunlight color that we've been using with our lights. So I'll pick that. Pretty good. That is a darker color than what it was by default, so we've lost something there. Intensity-wise, or density-wise, I should say. So to counteract that, let's bump this up a little, the density. And these settings are really touchy. So it doesn't take much. Take it up a little higher. Looks pretty good. These default settings are fine here. Now the start distance, go back to our main camera, and I want to push it back a little. I don't want the fog to be up in our face. So as I increase the start distance number, you can see that fog line jumping back or moving back. I'll put it back to 0. So where I want it is back here behind the ship, or to start somewhere right around where the ship is. I'll keep pushing it back. Looks pretty good. So I'll hit F to toggle fog on and off. You can see that it's fairly dense starting behind the ship, but that it's not so dense that we lose detail back here. It just gives depth, or adds depth to our scene. And that's fog, height fog anyway. That's all you need to know. Now that we're getting close to wrapping up the lighting for our scene, I'm ready to take a quick look at our post-process effects. To view post effects in the editor, click the icon with the G on it. Or even better, just hit the G key. To view our post-process settings, go to View, World Properties, World Info, Default Post-Process Settings. So what we're looking at are the default post-process settings that you get with every new Unreal level, except for one effect, real-time ambient occlusion. By default, ambient occlusion is enabled for all new Unreal levels. I disabled it until now because I didn't want it to distract or to interfere with our lighting process. To enable it, we'll just click this box next to Allow Ambient Occlusion. Nothing grounds the actors and ties your scene elements together better than ambient occlusion. Okay, the only other setting I'm going to change at this point is bloom scale. Right now it's at 0.2, so Let's bump it up a little bit to 0.5. You can watch this light here and this emissive green sphere. 0.2, the default, to 0.5. Let's exaggerate it a little bit. At this point, I'm pretty happy with our lighting. What I want to do is add some hand-placed point lights to accent the broad strokes we've been working with. To do that, first off, I'm going to make our lights level active. So let's go back to our content browser, level manager, and we'll double-click lights to make it current. Now, the first light I want to add is I want to add some small point lights to help sell these ceiling light sources. So what I'll do is I'll right click anywhere in the scene, add actor, add light, point. What that did was it broke our baked lighting, but that's okay, that's to be expected. So I'm going to hit F4 to get the properties on this point light. We'll change this color. Go to light component. What I want to do is pick this greenish color here that I have saved to help offset all of the warm color that we have going on in the scene right now from the sunlight and the bounce from that sunlight. Click OK. It might look a little extreme now, but when it bakes down, it tends to tone it down some. So the brightness for that guy, I'm going to make him 1.5. Then I want to scale it down. I'm hitting spacebar to flip through the transform modes again. You can scale it that way. You can also go down to, in the point light component, there's a radius here. So you can just type it in if you know what you want. So I'm going to try something small. And I'm going to place it directly underneath where our light source is. And that's going to hit the ceiling. I'm going to duplicate it by holding Alt and click dragging to make another one. I'm going to put this on the wall right next to it. And I'm going to make that one brighter. I'm totally exaggerating it at this point because I know when it bakes down, when that light bakes down to the light maps, we're going to lose a lot. So I want to add some small point lights to help make some of the rubble by the ship wing stand out. So I'm going to add an orange point light like it's coming from this emissive that'll hit some of this rubble. So a quick way to do that is just grab one of the lights already made, save some steps, click Alt, drag to duplicate it, then I'll move it over here where I want it. Go back to F4. I'm going to pick an orange light for that. So light component, back to the color. I have this orange light saved. Okay. Brightness doesn't need to be this hot. I'm going to take that back down. I'm going to make the radius a little larger. A lot larger, actually. And finally, I want some lights placed around this ship to help bring out some of its details. So just like before, I'm going to click Alt, drag to duplicate, hit F4 for the properties, and I'm going to use a green light color for that. I'll go back to this other green light that I used with the ceiling light sources. Turn it down. And the size on it's pretty good, the radius. One cool thing you can do is, as you're moving these, once you pick which direction, which axis you want to move it on, you can press G to go into game mode, and it'll hide that sprite so you can see what you're doing a little better. And then just hit G again to get out of it, click another access, hit G to go back into it. That's another thing I do all the time. And I want one more of those. So click Alt to duplicate. Okay, so off camera, I'm going to go and duplicate these lights that I placed for the ceiling light sources, so you don't have to watch me place all of them. I'm just going to Alt drag, duplicate them all around the room, and then I will bake lights and we'll see what we get. Here we see our new accent point lights and the rest of our lighting baked at the production quality level. It took an hour to bake, but I think it's worth it. As a finishing touch, I'll turn on levels that include God rays and stains that I placed in preparation for this video. Both the God rays and the stains are just cheap cards with unlit, translucent materials applied. There are better ways to produce these effects, but these serve our purposes just fine. All in all, I think the final lit version of our scene reads well and looks great. I hope you do too. Before we're done here, I want to draw your attention to the UDN Lightmass webpage located here. If you run into problems or are looking for a better description of Lightmass and its features, this UDN page dedicated to Lightmass is the most thorough resource you'll find. I suggest that you always check here first. At the end of a project, I always think it's fun to go back and flip through my progress screenshots. Here are some that I took as I was testing Lightmass in preparation for this video. I hope you've enjoyed this introductory look at Epic's Lightmass. My name is Jim Magill, and on behalf of Eat3D, I'd like to thank you for watching.